Hello everyone, welcome to Tech with Shaping Pixel. Today in this video, we are going to cover AWS Certified AI Practitioner full crash course. If you haven't subscribed to our channel, please subscribe to Tech with Shaping Pixel. Let's start our video.
The AWS Certified AI Practitioner exam begins with the fundamentals of artificial intelligence and machine learning. This domain covers 20% of the exam. Key topics include artificial intelligence concepts, machine learning lifecycle, and practical use cases like computer vision and natural language processing. Next is the fundamentals of generative AI, comprising 24% of the exam. You'll explore concepts like tokens, embeddings, and transformers. Understand generative AI's capabilities and limitations, and learn about AWS services like Bedrock and SageMaker Jumpstart for building applications. The largest domain, applications of foundation models, makes up 28% of the exam. Focus on design considerations, prompt engineering, and model evaluation. Learn to apply foundation models using AWS tools like Bedrock and SageMaker for real-world scenarios. Guidelines for responsible AI account for 14% of the exam. This domain emphasizes fairness, transparency, and bias reduction. Understand tools like SageMaker model cards and clarify to ensure AI systems are responsible and legally compliant. Finally, security, compliance, and governance for AI solutions cover 14% of the exam. Learn to secure AI systems using AWS services like IAM and MEC. Understand compliance regulations and governance standards to ensure your AI solutions meet all requirements. Generative AI is transforming our world at an incredible pace. To navigate this evolving landscape, understanding key vocabulary is essential. This lesson is designed for anyone interested in artificial intelligence, especially generative AI. We'll explore crucial terms that form the backbone of generative AI discussions. Whether you are in a technical or non-technical role, grasping these concepts will enhance your understanding and engagement in AI conversations. Let's start with foundational terms: artificial intelligence, machine learning, and artificial neural networks. Deep learning and generative AI are pivotal alongside foundation models and large language models. Natural language processing, transformer models, and generative pre-trained transformers are also key components. Next, we delve into responsible AI, labeled data, and learning types: supervised, unsupervised, and semi-supervised. Prompt engineering and chaining, retrieval augmented generation, parameters, and fine-tuning are vital for AI development. Finally, we cover bias, hallucinations, and temperature. Anthropomorphism, completion, and tokens are crucial, as are emergence in AI, embeddings, text classification, and context window. Understanding these terms will enrich your AI knowledge. Artificial intelligence, or AI, simulates human intelligence through computer systems. From small apps to large-scale enterprise solutions, AI performs tasks once requiring human intellect. Machine learning, a subset of artificial intelligence, enables systems to learn from data and experience. It uses algorithms to improve accuracy over time, identifying patterns, and making predictions. Artificial neural networks mimic the human brain's structure. These networks of interconnected nodes learn to recognize patterns, improving accuracy by learning from mistakes. Deep learning uses neural networks to analyze patterns in data. It identifies objects in images or transcribes audio to text, utilizing multiple network layers for complex pattern recognition. Generative AI, a deep learning subset, creates new content like images or text. It uses vast training data, producing human-like outputs through foundation models. Foundation models are large, unlabeled datasets forming the basis for generative AI. They interpret language, generate images, and support models like Stable Diffusion and GPT-4. Large language models generate text by predicting probabilities. They use billions of parameters to simulate human language, aiding in text summarization and chatbot creation. Natural language processing allows systems to understand and generate human language, both written and spoken, through natural language understanding and generation techniques. Transformer models process text, capturing relationships and enabling language translation and data transformation. Generative pre-trained transformers use deep learning to generate text, images, and audio, powering tools like ChatGPT. Responsible AI ensures artificial intelligence is used ethically and transparently. It involves principles and practices that govern AI's impact on humanity, embedding trust and confidence in AI models. Labeled data contains tags that help machine learning models learn from raw material. For example, a photo of a tiger might be labeled tiger to provide context. Supervised learning uses labeled datasets to predict outputs. Algorithms learn relationships between input and output data, correcting errors to improve accuracy over time. Unsupervised learning identifies patterns in unlabeled data. It autonomously classifies features like color or shape to differentiate between images such as tigers and elephants. Semi-supervised learning combines labeled and unlabeled data. A smaller labeled dataset aids in training, enhancing classification with unsupervised techniques. Prompt engineering refines input prompts for large language models, optimizing outputs. It transforms human AI interaction by adjusting prompts for more relevant responses. Prompt chaining creates conversational interactions with language models. It uses continuous prompts for contextual awareness, enhancing user experience and chatbots. Retrieval augmented generation supplements AI models with external data for accurate responses. It ensures up-to-date information like current stock prices. AI parameters are variables adjusted during training to optimize model performance, minimizing prediction errors, and enhancing efficiency. Fine-tuning adjusts pre-trained models on specific tasks, improving accuracy by adapting parameters to new data. Understanding these AI concepts is crucial for leveraging technology effectively. They guide the development of intelligent systems that are ethical, efficient, and responsive. Bias in machine learning occurs when data used to train models is distorted, leading to skewed results. High quality data is crucial to avoid biased outcomes. AI hallucinations happen when models generate false responses that seem factual. These can arise from biased data or misinterpretation, reminding us to verify AI outputs. Temperature in AI adjusts response randomness. A setting closer to 0 yields focused outputs, while higher values produce diverse responses. The default is typically 0.7. Anthropomorphism involves attributing human traits to non-human entities like AI. As AI evolves, people may anthropomorphize it, affecting interactions and perceptions. In natural language processing, completion refers to the generated response from a model. For instance, ChatGPT's answer to a query is its completion. Tokens are basic units of text input for language models. They can be words or parts of words, enabling models to process and generate responses effectively. Emergence occurs when AI models scale, leading to unexpected behaviors. These models learn and adopt without explicit training, posing potential risks and benefits. Embeddings are numerical representations of words or objects in multidimensional space. They enhance AI's ability to understand context in languages and images. Text classification trains models to label text based on content. Using natural language processing, it predicts sentiment, topics, and intent across various domains. Generative AI raises significant data privacy concerns. When using services like ChatGPT, both company and user data could be at risk. A breach in March 2023 exposed user information and chat histories. To protect data, read privacy statements, update privacy policies, and implement security checks. Anonymizing user data before using third-party services is crucial. Generative AI can inherit biases from its training data, perpetuating stereotypes. The Diffusion Bias Explorer, for example, shows gender bias in generated images of doctors and nurses. To combat bias, expand datasets, test for existing biases, and be transparent about them. Awareness allows for planning and mitigation, even if biases cannot be entirely removed. Generative AI also poses challenges for intellectual property and copyright. Using AI-generated content like images of iconic characters can infringe on existing copyrights. In the United States, AI-generated works are not eligible for copyright protection. As technology evolves, laws will adapt. Companies must question if AI tools violate intellectual property rights to avoid legal issues. Generative AI presents complex ethical and legal challenges, from data privacy to bias and intellectual property. Understanding these concerns is vital. As technology advances, staying informed and proactive is essential to navigate this rapidly changing landscape. Imagine you are a conductor leading an orchestra. Each instrument represents an AI capability, like text or image generation. Your goal? Harmony. This is where prompt engineering comes in, transforming how we interact with AI. Prompts are inputs guiding generative AI systems. They can be text, images, or even gestures. Text-based prompts are widely used, but remember, prompts come in various forms, each tailored to different AI systems. Prompt engineering is crafting prompts to achieve desired outputs. It's both an art and a science. The art lies in creativity, while the science involves refining prompts through iteration. Together, they ensure effective AI interaction. Generative AI is revolutionizing industries from content creation to code generation. Companies like Adobe and GitHub integrate AI into their products, enhancing user experiences. Prompt engineering bridges user intentions with AI responses, making natural language interfaces invaluable. Prompt engineering is an emerging field requiring creativity and experimentation. It's not a one-size-fits-all process, but mastering it unlocks AI's full potential. Embrace the challenge, and the rewards will be significant. Understanding generative AI models starts with knowing their parameters. Adjusting parameters like temperature, top P, and top K can drastically change responses. Different models have unique default settings, so tailor these for your specific use case. Each AI model has distinct capabilities and limitations. For instance, OpenAI offers various models, including language and image models. Even within a single type, models differ. Recognizing these differences is crucial for effective application. Imagine needing structured data from a language model. Some models offer function calling, returning data like JSON objects. This feature can save significant development time, highlighting the importance of knowing model functionalities. For tasks like analyzing healthcare records, a model with a large context window and domain expertise is essential. You might need a domain-specific model or a fine-tuned general-purpose model requiring substantial data and effort. In summary, understanding the capabilities and limitations of generative AI models is vital. This knowledge helps craft effective prompts and achieve accurate responses. Stay informed to make the most of these evolving technologies. Crafting effective prompts for AI models is both an art and a science. There's no one-size-fits-all approach, so it's crucial to experiment and refine your process continuously. Start by clearly defining your objectives. Are you aiming for a specific response or format like JSON or Markdown? Be flexible, as objectives can evolve based on feasibility and complexity. Once objectives are set, establish a verification method. This could be expert review or automated testing. Start simple and iterate, allowing your verification process to evolve as needed. Choose a model that balances accuracy and cost. For instance, OpenAI's GPT 3.5 Turbo is a good starting point. Experiment with multiple models to find the one that meets your needs. Begin with a verbose prompt and refine it. Test how changes affect responses, focusing on critical load-bearing words. Aim to make the prompt concise without losing accuracy. Document your process, including models and parameters tested. This saves time and aids understanding when revisiting prompts. A record of your decisions is invaluable for future reference. In the world full of prompt engineering, standard prompts are foundational. They guide models towards specific responses, forming the basis for more advanced strategies. Instructional prompts are directives that tell the model to perform tasks. For example, translate this text into French or describe photosynthesis. These prompts reduce ambiguity and experimentation, making them ideal for tasks with measurable outcomes like translation and summarization. Question-based prompts pose questions to the model, such as, "What is photosynthesis?" These prompts encourage creativity and are useful for conversational interactions like chatbots and customer support. They allow the model to explore connections that might not be immediately obvious. Questions can be open, closed, or leading. Open questions like, "How has chocolate influenced humanity?" allow expansive answers. Closed questions such as, "Is chocolate a good source of antioxidants?" expect specific responses. Leading questions guide the model towards a particular answer. Instructional and question-based prompts each have strengths. Instructional prompts are explicit, ideal for tasks with clear outcomes. Question-based prompts foster exploration and creativity. Both can be used together depending on the use case and personal preference. Experiment to find what works best for you. Contextual prompts built on standard prompts by adding a narrative element. Unlike simple instructions, they set a scene or role for the model, enhancing engagement and creativity. Role-playing prompts immerse the model in a specific role, like a history teacher or Shakespeare. "What is your creative process?" Answer as if you are Shakespeare. These prompts explore different perspectives, making interactions more dynamic and insightful. Scenario-based prompts set a specific situation such as, "Today is a rainy day in London, 1856. The model responds within this context, offering insights into specific times or events. These prompts are useful for exploring complex scenarios safely. Role-playing and scenario-based prompts can be combined for richer interactions. For example, you are a chef in Paris, 1856, preparing a meal for important guests. This approach enhances the model's ability to simulate realistic situations. To craft effective prompts, define objectives and context rules, including time, place, and role. Iteratively refine the prompt for accuracy and realism. This process ensures the model consistently delivers the desired response, enhancing its utility across various applications. Few-shot learning is a powerful technique that helps models learn new tasks with minimal examples. By providing context, it guides models to understand tasks better. Let's explore how few-shot prompts enhance model performance. Consider sentiment analysis. A few-shot prompt might include examples like, "The rooms were clean," positive, "and the service was slow," negative. When asked to analyze, "The movie was okay but predictable," the model predicts neutral by balancing positive and negative cues. Zero-shot prompts offer no examples, relying on the model's existing knowledge. One-shot prompts provide a single example, while few-shot prompts offer multiple examples. Each approach varies in guidance, impacting the model's understanding and output quality. Few short prompts help models recognize patterns, producing consistent results. They clarify expectations, offering a clearer picture of desired outcomes. More examples often lead to better performance, especially for complex tasks. Now try creating a few short prompts for funny product descriptions. Use items like chocolate toothpaste or edible earbuds. Include 3 to 5 examples. Chain of thought prompts help language models like GPT 3.5 Turbo tackle complex tasks by breaking them into smaller steps. Despite advances, these models struggle with intricate reasoning such as arithmetic or common sense tasks. Consider this scenario. A cafeteria starts with 23 apples, uses 10 for a pie, 2 employees share an apple, and receives 9 more. How many apples remain? The model initially answered incorrectly, subtracting 2 apples instead of 1. The model broke down the problem but made a mistake, misunderstanding that the employees shared a single apple. GPT-4, however, solved it correctly by using Python code to calculate the answer. To improve reasoning, prompts like consider phrasing for singular or plural were used. This guided the model to correctly identify the shared apple, resulting in the accurate count of 21 apples. When crafting prompts, consider the model's capabilities. Break problems into steps and guide the model with specific instructions. Remember, generative AI can confidently err, so always verify responses. Use prompts to steer models toward accurate outcomes. Generative AI models can confidently provide inaccurate information, making verification crucial. Understanding accuracy is key to evaluating AI responses effectively. A lawyer used ChatGPT to draft a legal brief, citing 6 fabricated cases. This highlights the importance of verifying AI generated content, as blind trust can lead to significant errors. Accuracy varies by context. For document summaries, it means aligning with the original content. In fantasy worlds, it means maintaining consistency with established lore. Define accuracy based on your specific use case. Prompts significantly influence response accuracy. Leading prompts can guide models towards inaccuracies. For instance, asking for justifications for false premises can result in fabricated responses. Specific prompts help achieve accurate outcomes. Bias in prompts and models can skew responses. For example, asking for generalized gift ideas based on gender introduces bias. Understanding and avoiding bias is essential for accurate AI interactions. Evaluating AI accuracy involves understanding context, crafting precise prompts, and recognizing bias. By doing so, you can guide AI models towards more reliable and accurate responses. Unstructured data is the simplest format for text-based generative AI. It involves raw responses without additional formatting. This is ideal for content consumed as plain text, like text-to-speech applications, where simplicity and efficiency are key. Loosely structured data enhances readability with minimal syntax like Markdown. Markdown allows for headings, bold text, and bullet points. It's commonly used in applications like ChatGPT to create more engaging user experiences. Highly structured data formats such as JSON, YAML, and XML are used for software consumption. These formats are strict and less forgiving of errors, making them essential for configuration files and data exchange in software development. Producing highly structured formats can be challenging. Language models are non-deterministic, meaning responses can vary. Formats like JSON require strict adherence to rules, and generating them can be token-intensive and costly. To use standard formats effectively, separate formatting from content generation. Use models fine-tuned for specific formats and configure parameters like temperature for consistency. This approach enhances flexibility and reduces errors. Custom formats simplify structured data generation for specific use cases. They can be more efficient than standard formats, especially when simplicity and post-processing are feasible. Consider the cost and effort before choosing this option. Language models excel at producing grammatically correct responses due to extensive training data. They can enhance human written content by correcting grammar and syntax. For critical documents like legal briefs, human review and tools like Grammarly are recommended. Style and tone depend on context. For instance, legal documents require formality while blogs can be casual. Models can adapt with prompts like formal or casual. Ensure the response aligns with the intended style and tone for the situation. Emotion and sentiment add depth to responses. They are crucial in creative writing and marketing. Models vary in handling these nuances. Use prompts to specify desired emotions, considering word choice and punctuation to convey the right sentiment. Design prompts carefully to control response qualities. Include specific objectives for grammar, style, tone, and emotion. Avoid leading prompts that bias results. Understand the model's capabilities and tailor prompts to achieve desired outcomes. Controlling response qualities is achievable with the right prompts and models. Always involve humans in the verification process to ensure accuracy. Understanding model capabilities and prompt design is key to success. Welcome to Amazon Bedrock, a managed service designed to help you build and scale generative AI applications. This lesson is tailored for application developers focused on generative AI, but it's also beneficial for anyone interested in AWS Gen AI offerings. Amazon Bedrock empowers you to explore various foundation models. At the time of this lesson, it supports multiple models, allowing you to experiment and innovate. Stuart Scott, AWS Content Director at Cloud Academy, emphasizes the importance of understanding these capabilities for effective application development. With Amazon Playgrounds, you can experiment with running inference while model evaluations let you compare and analyze different model performances. Understanding these evaluations is crucial for optimizing your AI applications and ensuring they meet your organizational needs. Setting up your APIs with Amazon Bedrock is fundamental. This process ensures seamless integration and functionality of your generative AI applications, enhancing their performance and scalability within your organization. Amazon Bedrock is a managed service by Amazon Web Services or AWS that provides access to various foundation models through API calls. These models include those curated by AWS and third-party providers like Coher and Stability AI. Foundation models are large-scale models trained on extensive unlabeled datasets. They serve as the backbone for generative AI applications. These models can interpret language, engage in conversation, and generate images with high accuracy. Amazon Bedrock integrates with leading foundation model providers. A121 Labs focuses on large language models for tasks like summarization and ideation. Amazon's Titan model excels in text generation. Anthropic offers diverse text tasks while Coher specializes in language understanding. Meta's Llama 2 is for chat applications, and Stability AI's SDXL models generate detailed images. Amazon Bedrock simplifies the development of generative AI applications by providing easy access to foundation models. It offers features like playgrounds and model evaluations to help identify the most suitable model for your needs, streamlining the process significantly. When you start with Amazon Bedrock, your AWS account won't have access to foundation models. An administrator must add these models using the Amazon Bedrock dashboard console. This ensures that only authorized users can utilize the models for their specific needs. Choosing the right model depends on your business use case. For text or chat applications, you might opt for models by Coher or Anthropic. If image creation is your goal, Stability AI models are more suitable. The selection process is crucial for optimal performance. Access to models is controlled in the Model Access section of the Bedrock console. Here, you can navigate through different model providers. The interface allows easy expansion or collapse of options, showing which models are available and which have been granted access. To request access to a new model, select Manage Model Access and choose your desired models via tick boxes. Once requested, your access will be marked as In Progress. After approval, your AWS account administrator will receive an email confirming the marketplace approval. The model status will update to Access Granted, allowing users to utilize the model. Amazon Bedrock's Playgrounds let you experiment with model inference using various foundation models. This user-friendly interface supports text, chat, and image-based applications, offering flexibility for your generative AI projects. Experimentation in these playgrounds involves adjusting prompts and inference parameters to align with your use case. Prompt engineering refines inputs for large language models, optimizing outputs for specific tasks by manipulating prompts. Different models offer varied inference parameters. For example, Jurassic 2 made by A121 Labs includes randomness, length, and repetition settings. Adjusting these can significantly influence the model's response, tailoring it to your needs. Consider the temperature parameter. Setting it to 0 yields focused responses, while 0.9 point 0.9 results in diverse outputs. For instance, asking when is the best time to visit London with different temperatures showcases this variance. Playgrounds also provide model metrics, displaying latency, token counts, and costs. These metrics help evaluate model performance, guiding you to select the best model for your requirements. Amazon Bedrock's playgrounds empower you to fine-tune AI models, enhancing their relevance and efficiency for your specific applications. Bedrock offers automatic model evaluations to assess AI models. This process involves selecting a foundation model, task type, and metrics like toxicity and accuracy. Users can choose datasets, specify storage on Amazon S3, and assign an IAM role for permissions. The evaluation generates a scorecard, providing insights into model performance. This method is efficient for understanding model capabilities without human intervention. For a more nuanced approach, Bedrock allows human-involved evaluations. Users can bring their own team or use an AWS-managed team. This method includes selecting models, task types, and defining metrics. Human evaluators assess model responses, ensuring alignment with organizational style and tone. This approach offers flexibility, allowing custom tasks and metrics, and provides a deeper understanding of model suitability for specific use cases. AWS managed work teams offer another evaluation option. Users name their evaluation, consult with AWS, and finalize requirements. This involves defining task types and expertise areas needed. AWS assembles a workforce to evaluate model responses, ensuring comprehensive analysis. This method is ideal for organizations seeking expert input and a thorough evaluation process, leveraging AWS resources for optimal model assessment. Amazon Bedrock APIs can be accessed using the AWS Software Development Kit. Supported languages include C++, Go, Java, JavaScript, .NET, Python, and Ruby. Each SDK has its own method for interacting with Bedrock APIs. For detailed API references, consult the AWS documentation. To use AWS command line interface, download and install it. Then configure it using the AWS configure command. Ensure you have permissions to access Amazon Bedrock. For specific Bedrock command line interface commands, refer to the associated documentation for guidance. With Amazon SageMaker notebooks, ensure the role has permissions to access Amazon Bedrock. This involves setting an inline policy and defining a trust relationship. The role must allow service principals for both Bedrock and SageMaker. Using Python's Boto3 SDK, you can perform API operations seamlessly. In summary, Amazon Bedrock APIs can be accessed through the AWS SDK, AWS command line interface, or SageMaker notebooks. Each method requires specific configurations and permissions. For comprehensive guidance, always refer to the official AWS documentation. This ensures you leverage the full potential of Amazon Bedrock's capabilities. Amazon Bedrock foundation models offer broad capabilities, but sometimes you need them to specialize. Customizing these models allows them to excel in specific domains like healthcare by understanding unique terminology and context. There are several ways to customize foundation models: prompt engineering, retrieval augmented generation, fine-tuning, and continued pre-training. Your choice depends on your specific needs. For simple tweaks, prompt engineering might suffice, while complex tasks may require more intensive methods. Fine-tuning adjusts models for specific tasks like changing style or summarizing data. Continued pre-training enhances domain-specific knowledge, such as healthcare terminology. You can combine these methods, starting with domain training and then refining task accuracy. Not all models support both techniques. Continued pre-training is available for Amazon Titan Text Z1 Express and Z1 Lite. Fine-tuning is supported by models like Meta Llama 2 and several Amazon Titan Text variants. Check for updates on supported models. Customized models can be used in Bedrock playgrounds or via API. You'll need provisioned throughput to run inferences. Bedrock keeps your data secure within your virtual private cloud, and you can share or copy models across accounts and regions. Fine-tuning an Amazon Bedrock model optimizes it for specific tasks. You'll need a small labeled dataset with examples of prompts and completions structured in a JSON file format. This helps the model learn how to respond to specific prompts effectively. For text-to-image models, include image locations alongside prompt text. Continued pre-training enhances a model's performance in a specific domain. Unlike fine-tuning, it requires a large, unlabeled dataset, also in JSON format. This dataset provides raw input, helping the model learn domain-specific knowledge. It's ideal for sectors needing specialized language or terms. To customize a model, navigate to the Bedrock console. Choose Customize Model and select either a fine-tuning or continued pre-training job. Specify the base model, name your job, and upload your dataset to an S3 bucket. Adjust hyperparameters based on your chosen base model. Once customized, test your model in a playground or use it for inference via the API. Ensure you have the necessary provision throughput. Fine-tuning uses a small labeled dataset, while continued pre-training requires a large unlabeled one. Both methods output a model ready for testing and application use. Provision throughput is essential for running custom models in Amazon Bedrock. It ensures consistent performance by allowing you to specify the throughput needed for your model. Unlike on-demand mode, it requires a long-term commitment. In the Bedrock console, provision throughput is found under Assessment and Deployment. To purchase it, you select the model, whether base or custom, and specify your commitment duration. This setup is crucial for maintaining performance consistency. You can choose from no commitment, 1 month, or 6 months. With no commitment, you can delete throughput anytime. However, with 1 or 6-month commitment, deletion isn't possible until the term ends, ensuring stable performance. Model units determine the performance level. AWS suggests contacting an account manager for model unit details. With no commitment, you get 2 model units by default. Longer commitments allow more model units, enhancing throughput for your model. Once purchased, provisioned throughput is fixed. You can test models in the Bedrock playground and deploy them using the Bedrock API. This setup ensures your custom models run efficiently with the specified throughput. Amazon Bedrock knowledge bases are powerful tools for building generative AI applications. They allow you to use external data sources, enhancing the capabilities of foundation models supported by the service. Retrieval augmented generation is a framework that enriches AI models with external factual data. This ensures responses are accurate and up to date. For instance, retrieval augmented generation can fetch the latest stock information for Amazon from external sources. Knowledge bases operate in two stages: preprocessing and runtime execution. They interpret external data and generate responses by combining foundation models with additional data sources, ensuring responses are both relevant and accurate. During preprocessing, data is divided into manageable chunks and transformed into embeddings using an embeddings model. These embeddings are stored in a vector index, capturing the semantic essence of the data for effective comparison with user queries. In runtime execution, user queries are translated into vectors. These vectors are matched against the vector index to find semantically similar document segments. The model then uses this context to generate tailored responses, enhancing user interaction. Start by naming your knowledge base and adding a description. Choose an identity and access management role with permissions to access services like Amazon Bedrock, Amazon S3, and more. You can let Bedrock create a new role or use an existing one. Optionally, use Key Management Service for encryption. Next, configure your data source. Provide a name and Universal Resource Indicator link for data stored on Amazon S3. Supported formats include text, Markdown, HTML, Word, Excel, and more. If encrypted, provide the Key Management Service key. Choose a chunking strategy to segment data before embedding. Choose an embedding model and create a vector store. You can quickly create an Amazon open source serverless vector store, ideal for development. Alternatively, select an existing store like Amazon Aurora or Redis Enterprise Cloud. Consider redundancy and encryption options for added security. Finally, review your selections. Once satisfied, create your knowledge base. This initiates data preprocessing and vector store creation, which may take time. After creation, sync your data sources to ensure they are indexed and ready for queries. Remember, any data source changes require an incremental sync. Amazon Bedrock agents are automated helpers in your AI applications, streamlining development and user interactions. They integrate foundation models with data sources, enhancing orchestration processes. Agents allow development teams to focus on business objectives, reducing coding tasks, timelines, and costs. They facilitate seamless integration, managing user engagement and API requests efficiently. Agents enhance customer experience by automating tasks like booking reservations. They converse naturally with users, confirming details and enriching interactions, offering advanced automation and responsiveness. Fully managed by Amazon Bedrock, agents eliminate infrastructure management concerns. They handle encryption, permissions, and prompt engineering, ensuring operational efficiency and user satisfaction. Agents converse in natural language, execute user requests, break down tasks, make API calls, integrate with knowledge bases, and manage source attribution, enhancing response accuracy and efficiency. Agents operate in build time and runtime phases. Build time involves configuration and implementation, while runtime includes pre-processing, orchestration, and post-processing, ensuring valid requests and comprehensive responses. Creating an agent in the AWS Management Console involves 4 key steps. This process is accessible via the AWS Bedrock dashboard under Orchestration, where you can manage your agents. Step 1. Begin by entering your agent's name and optional description. This step sets the foundation for your agent's identity and purpose. Ensure clarity and specificity in these initial details for effective setup. Step 2. Configure IAM permissions. These permissions allow your agent to access necessary AWS services. You can create a new service role or use an existing one, ensuring it has access to Bedrock models, Amazon S3 schemas, and KMS keys. You can enhance your agent with optional features like action groups and knowledge bases. Action groups automate tasks, while knowledge bases enable the agent to perform queries. Define clear instructions for these components to optimize functionality. Advanced prompts involve customizing templates for processing user input and generating responses. This step enhances your agent's accuracy and performance through few-shot prompting and tailored examples. Once configured, save your agent as a working draft. Test its functionality to ensure it meets expectations. Use the invoke agent request to communicate with your agent, refining it for optimal performance. Amazon Bedrock ensures your data is secure with robust encryption. Customer data, including user prompts and model responses, is encrypted in transit using TLS 1.2 and 1.3 and at rest with customer managed keys via the AWS Key Management Service. This allows precise control over data access through key policies. Privacy is a top priority in Amazon Bedrock. AWS guarantees that your data will not be used to train Amazon Titan or other foundation models. When fine-tuning models, Bedrock creates a unique copy for private training, ensuring full control over data sharing and usage. Amazon Bedrock offers comprehensive identity and access management features. By leveraging AWS Private Link, you can ensure that traffic between your virtual private cloud and Bedrock remains private, never traversing the public internet. Custom endpoint policies further restrict access, enhancing security. Bedrock supports auditing and compliance by providing features that align with legal requirements. These tools help maintain governance and ensure that AI interactions adhere to organizational policies, keeping data secure and interactions appropriate. Guardrails in Amazon Bedrock enable safe AI experiences by applying controls based on user inputs and model outputs. These features ensure AI interactions align with corporate policies, maintaining a responsible and secure environment for generative AI applications. Identity and access management is crucial for managing access in Amazon Bedrock. You can use identity-based policies to control access via the AWS console, command line interface, or API. Managed policies offer full or read-only access, while custom policies provide granular controls. Attribute-based access control is also available. Auditing is essential for monitoring user activity in Amazon Bedrock. AWS CloudTrail tracks API calls and user actions, while Amazon CloudWatch monitors key metrics. Model invocation logging supports full audit tracing by storing input, output, and metadata in CloudWatch logs or S3, ensuring comprehensive visibility. Amazon Bedrock supports data sovereignty by storing data in the AWS region used. It's compliant with standards like ISO, SOC, and CSS Star Level 2 and is HIPAA eligible. Bedrock also aligns with GDPR in the European Union. AWS Artifact provides detailed compliance information. Building responsible AI applications with Amazon Bedrock involves using guardrails. These tools help ensure ethical AI development by providing guidelines and best practices. By leveraging Bedrock's robust access control, auditing, and compliance features, you can create secure and compliant AI solutions. Amazon Bedrock introduces guardrails, a feature designed to ensure responsible AI interactions by providing administrators with control over user inputs and model outputs. With the rise of AI systems, misuse has become a concern. Users may submit inappropriate prompts or manipulate models, leading to harmful outputs. Guardrails addresses these issues by enhancing security. Guardrails offer four categories of policies. Denied topics prevent discussions on sensitive subjects like politics. Content filters set thresholds for harmful content, ensuring applications remain respectful. PII redaction protects user privacy by removing personal information. Word filters block profanity and competitor names, maintaining professionalism. These policies provide an extra layer of protection beyond existing model safeguards. Guardrails can be applied consistently across all applications using Amazon Bedrock, including autonomous assistants known as agents. This ensures a uniform approach to security and appropriateness in AI interactions. Guardrails in Amazon Bedrock empower developers to maintain safe and appropriate AI interactions, enhancing user experience and trust. Amazon SageMaker is a fully managed service designed for data scientists, machine learning engineers, and developers. It enables users to build, train, and deploy machine learning models efficiently. SageMaker offers environments like Studio, Studio Classic, and Studio Lab. SageMaker supports various integrated development environments including code editor and notebook instances with pre-installed libraries like TensorFlow and PyTorch. These tools facilitate tasks such as coding, data exploration, and visualization, streamlining the machine learning workflow. The first step in the workflow is data preparation, often the most time-consuming. It involves collecting, cleaning, and transforming data. This foundational step is crucial as it can take up to 60 to 80% of the total project time. Once data is prepared, the next steps are building and training the model. SageMaker offers frameworks and pre-trained models to assist in this process. Training involves setting up runs, evaluating conditions, and tuning hyperparameters for optimal performance. After training, models are deployed into production. Continuous monitoring is essential to manage the model's life cycle, detect data drifts, and ensure hardware scalability. This ongoing process ensures the model remains effective over time. When building machine learning models with Amazon SageMaker, data quality is crucial. The saying garbage in, garbage out holds true. Ensuring your data is clean and well structured is essential. Start by cleaning your data stored in Amazon S3. Remove duplicates and fix structural issues. Handle null values by removing records or irrelevant columns. This ensures your dataset is ready for modeling. Transformations are key. Encode non-numeric fields, normalize numeric data, or apply logarithmic transformations to manage skewed data. These steps prepare your data for effective machine learning model training. Depending on dataset size, sample, or argument data, sampling balances efficiency and cost while creating a testing dataset. This step is vital for validating model performance. Amazon SageMaker offers tools like Data Wrangler and Ground Truth. Data Wrangler simplifies data preparation with a visual interface supporting over 40 data sources. It enables repeatable, automated workflows. Ground Truth aids large-scale data labeling. It offers semi-automated solutions using Mechanical Turk, third-party vendors, or your team. Choose between automatic or human labeling for accuracy and efficiency. SageMaker notebook instances are managed by Jupyter Notebooks that simplify building machine learning models. They come pre-configured with essential libraries and tools supporting frameworks like TensorFlow, PyTorch, and scikit-learn without the hassle of managing infrastructure. To create a notebook instance, name it and select an instance type. Larger instances process data faster but cost more. Choose between Jupyter Lab version 1 or 3, specify an IAM role, and optionally select a KMS key and VPC. Once your instance is ready, open Jupyter or Jupyter Lab. The environment may seem empty initially, but the SageMaker Examples tab offers numerous example notebooks covering topics from Amazon algorithms to reinforcement learning and the SageMaker Python SDK. For instance, to test the k-nearest neighbors algorithm, use the relevant example notebook. It includes annotations, sample data, and code guiding you through data interpretation and model building, eliminating the need to start from scratch. SageMaker Autopilot automates model building by selecting optimal algorithms, while SageMaker Zemstat provides pre-trained models and templates. These features streamline the machine learning process, making it accessible even without extensive expertise. Training your machine learning model with Amazon SageMaker involves selecting algorithms, setting up training jobs, and tuning hyperparameters. SageMaker offers a robust platform for handling large datasets efficiently. Start by selecting an algorithm. SageMaker provides over 15 built-in algorithms for tasks like supervised learning and natural language processing. You can also use custom or third-party algorithms from the AWS marketplace. Create a training job by naming it and assigning an IAM role. Choose your algorithm and decide on the input mode, file or pipe. File mode suits smaller datasets, while pipe mode strains data for larger ones. Configure input data channels from sources like S3 or EFS. Separate channels for training and testing data, ensure your model is trained and evaluated efficiently. Specify an S3 output path for storing results. Select hardware resources including instance type and storage. Consider using spot instances for cost savings. Set hyperparameters specific to your algorithm and use tuning jobs to optimize them for better results. SageMaker Debugger, and distributed training enhance your training process by identifying issues and scaling jobs. Explore hands-on labs to gain experience. Next, deploy your model to complete the workflow. Deploying machine learning models with Amazon SageMaker offers 4 inference options: real-time, serverless, asynchronous, and batch transform. Each serves unique needs. Real-time inference uses provisioned endpoints for immediate responses, ideal for low latency needs. Serverless endpoints, on the other hand, scale automatically and charge based on usage. They support up to 6 GB of RAM and are suitable for workloads without sub-second latency requirements. Asynchronous inference queues requests handling larger payloads or longer processing times. It notifies you upon completion and allows data capture for further analysis. This option is useful for integrating into machine learning workflows. Batch transform jobs process large datasets without persistent endpoints. Specify instance type, count, and S3 paths for input and output. They handle gigabyte scale payloads and can run for days. Post-deployment, continuous monitoring is crucial. Data drift and paradigm shifts can affect model performance. Tools like SageMaker shadow tests help assess changes by mirroring production traffic to shadow models. For hands-on experience, explore SageMaker notebooks. Foundation models are revolutionizing AI and machine learning, offering pre-trained, customizable solutions for diverse applications. But how can organizations access these models easily and affordably? Amazon Web Services introduces Amazon SageMaker Substart, a service embedded in SageMaker Studio. It provides a hub of popular foundation models like GPT and Llama 2 for easy access and customization. Jumpstart offers 2 main functions: a hub of pre-trained models and example scripts for training and inference. It includes proprietary models from AI21, Coher, and Lighton, and public models from Hugging Face, Meta, and Amazon, covering text generation, image generation, and more. Access Jumpstart via SageMaker Studio or the SageMaker console. Browse models under the Foundation Models section, view details, and explore demo code. Ensure you have a SageMaker domain set up to use models in notebooks. In SageMaker Studio, you can train, deploy, and evaluate models. Fine-tune models with new datasets, deploy for real-time inference, and evaluate performance against benchmarks. Jumpstart simplifies foundation model access while offering control over infrastructure and deployment. Foundation models are versatile, but to tailor them for specific tasks, customization is key. Prompt engineering is the first step in this process. It involves crafting inputs to guide the model's output, ensuring it aligns with your needs. There are several techniques in prompt engineering. Zero-shot prompts lets the model rely on its existing knowledge without examples. If this doesn't suffice, few-shot prompting can be used. This involves providing examples within the input to guide the model's responses. By doing so, you can better steer the output to match your requirements. Adjusting inference parameters can further refine model responses. For instance, the temperature parameter controls randomness. A high temperature leads to more varied outputs, while a low temperature results in more predictable responses. This allows you to fine-tune the model's behavior. In summary, prompt engineering is a powerful tool for customizing foundation models. By using zero-shot and few-shot prompting and tweaking inference parameters, you can effectively control the model's output. This approach ensures the model meets your specific needs. Customizing your model with Jumpstart offers three main approaches: prompt engineering, fine-tuning, and retrieval augmented generation. Large language models are generalists, but sometimes you need a specialist. Fine-tuning allows you to train a model on a specific dataset, making it adapt in a particular domain like finance. This process, known as domain adaptation fine-tuning, enhances the model's ability to handle specialized tasks. Instruction-based fine-tuning involves training the model with a dataset of instructions and expected outputs. This method helps the model follow instructions more accurately, making its responses more useful. To fine-tune your models, use Jumpstart in SageMaker Studio. Select your model, click Train, and upload your dataset to Amazon S3. Specify the dataset's URI and adjust hyperparameters to suit your needs. Hyperparameters vary depending on the model. Retrieval augmented generation is more complex but cost-effective long-term. It retrieves data from external sources like corporate documents using embeddings. This method allows the model to access relevant information beyond its initial training, enhancing its contextual understanding. Large language models can sometimes provide incorrect or biased answers. Evaluating these models for quality and responsibility is crucial. SageMaker Jumpstart offers a streamlined way to perform these evaluations. SageMaker Jumpstart models come with built-in evaluation capabilities through the SageMaker Studio environment. These are powered by SageMaker Clarify Foundation Model Evaluations. Foundation model evaluations allow you to assess models' outputs against specified benchmarks using open source or custom datasets. There are two types of evaluations: automated and human evaluation jobs. Automated evaluations score models on accuracy, semantic robustness, factual knowledge, prompt stereotyping, and toxicity. For subjective domains, human evaluation jobs are recommended to assess aspects like helpfulness. Choose the evaluation type, tasks, and prompts such as text summarization or question answering. Select a dataset and an output S3 bucket for results. An EC2 instance is required for processing, with size depending on dataset volume. Access the evaluation report in your S3 bucket. Evaluating large language models with SageMaker Jumpstart ensures they meet your quality and responsibility standards. By leveraging foundation model evaluations, you can tailor evaluations to your business needs. Machine learning operations is a methodology that applies DevOps practices to machine learning. It automates the lifecycle of machine learning algorithms from initial training to deployment and retraining with new data. Amazon SageMaker is a popular choice for organizations embracing MLOps. It offers specialized tools that streamline the machine learning lifecycle, enabling teams to efficiently build, train, deploy, and manage scalable models, enhancing collaboration and process efficiency. SageMaker integrates with DevOps tools like AWS Code Commit, Code Build, Code Deploy, and Code Pipeline. This integration supports continuous delivery and deployment pipelines, allowing rapid adaptation and launch of new features crucial for frequently updated machine learning models. Monitoring model performance manually is time-consuming. Amazon SageMaker Model Monitor automates this by tracking model quality in production. It detects model and concept drift, sending alerts to data scientists for timely retraining and issue resolution. SageMaker pipelines automate the entire model building process, from data preparation to validation. They offer flexible execution options, running on schedules or triggered by events, ensuring consistent, efficient workflows for quick experimentation and retraining. Amazon SageMaker Studio is a comprehensive integrated development environment for machine learning. It combines key functionalities into one user-friendly platform, allowing users to write code, visualize data, debug, track models, and monitor performance seamlessly. SageMaker Studio offers a flexible interface and integrates with SageMaker's workflow tools like SageMaker pipelines. This integration automates and manages end-to-end machine learning workflows, streamlining processes for MLOps teams and enhancing productivity. SageMaker Debugger addresses training challenges like overfitting and vanishing gradients. It provides insights and recommendations to improve model performance, alerts users to anomalies, and helps identify root causes through visualization of metrics and tensors. Amazon SageMaker Model Monitor continuously checks models in production for anomalies like data drift. It compares current data to training data, alerting users to deviations that may affect accuracy, ensuring models remain effective over time. SageMaker's experiment management helps organize, track, and compare machine learning experiments. This feature accelerates the transition from experimentation to production, maintaining an organized workflow and allowing teams to focus on core machine learning tasks. Amazon SageMaker Model Building Pipelines is a workflow orchestration service designed to automate every phase of the machine learning process. It integrates continuous integration and continuous delivery practices, optimizing training and deployment capabilities while reducing the need for extensive workflow tools. SageMaker Pipeline simplifies workflow creation with pre-built templates, allowing even those with limited continuous integration and continuous delivery knowledge to implement them. Pipelines can be built using the SageMaker Python Software Development Kit or the SageMaker Pipeline Definition JSON schema. Pipelines are organized using directed acyclic graphs, which define the execution order of steps. Each step performs a specific task like data preprocessing or model training, ensuring a smooth, one-directional flow of data. Dependencies between steps are managed using inputs and outputs. SageMaker ensures correct execution order, and a retry policy can mitigate step failures due to resource constraints. This enhances pipeline resilience by allowing retries for transient issues. Amazon SageMaker Studio allows users to monitor pipeline executions, view directed acyclic graphs, and track runtime metrics. Integration with Amazon Event Bridge enables automatic pipeline execution based on specific events, enhancing workflow efficiency and automation. Discover how Kubernetes orchestration with SageMaker operators and components enhances machine learning workflows on AWS. These tools integrate SageMaker into Kubernetes, streamlining training and inference tasks efficiently. Amazon SageMaker operators for Kubernetes simplify managing containerized machine learning models. They allow users to handle SageMaker resources like training jobs and model deployment directly within Kubernetes, bridging the gap between DevOps and machine learning. Kubeflow Pipelines is a platform for building scalable machine learning workflows using Docker containers. It enables data scientists to create end-to-end workflows in Python, manage pipeline definitions, and run experiments seamlessly. Integrating SageMaker with Kubernetes offers control, portability, and serverless capabilities. It eliminates the complexity of managing infrastructure, ensuring optimal utilization, cost efficiency, and high availability for machine learning workloads. SageMaker components for Kubeflow pipelines allow users to create and monitor SageMaker tasks directly. These components, available in two versions, enable data processing and training jobs to shift from Kubernetes clusters to SageMaker, leveraging its powerful features. Components like ground truth, work team, and data processing streamline various tasks within Kubeflow pipelines. Amazon SageMaker projects and templates are essential tools for organizations aiming to standardize environments for data scientists and create continuous integration and continuous deployment systems for machine learning operations engineers. They facilitate efficient code sharing and ensure consistent quality. SageMaker provides ready-made templates to kickstart machine learning workflows and CI/CD processes. These templates integrate with AWS tools like Code Build, Code Commit, and Code Pipeline, as well as third-party tools like GitHub and Jenkins, offering flexibility in project setup. The MLOps template supports model building and training, managing data processing, feature extraction, and model testing. It includes an AWS Code Commit repository with sample Python code and an AWS Code Pipeline for automating pipeline execution and artifact storage. If pre-made templates don't meet specific needs, organizations can create customized templates. This allows for integrated setups in AWS Code Pipeline, providing an additional layer for managing code and implementing operational best practices. The model deployment template streamlines deploying models from the SageMaker model registry to endpoints. It includes configuration files, AWS CloudFormation templates, and a code pipeline for deploying models to staging and production environments triggered by CloudWatch events. Machine learning governance is crucial as it provides a framework of best practices and guidelines to ensure machine learning models are accurate, fair, compliant, and trustworthy. With machine learning models powering critical systems like healthcare and banking, governance ensures visibility into the entire machine learning lifecycle, mitigating risks of inaccuracies and ethical breaches. Governance addresses both technical and ethical aspects. Technically, it prevents failures in service level agreements and incorrect results. Ethically, it avoids bias and illegal advice, safeguarding company reputation. Implementing governance involves challenges like setting permissions for stakeholders, sharing models across accounts, and managing model details. Manual tools can be inconsistent, delaying progress and complicating administration. To tackle these challenges, centralized tools like Amazon SageMaker offer solutions. They automate model details, monitor performance, and alert on drift, streamlining governance and ensuring consistent, reliable machine learning processes. Amazon SageMaker Role Manager simplifies assigning permissions to engineers, data scientists, and stakeholders accessing your SageMaker models. It helps manage permissions while adhering to the least privilege principle. SageMaker Role Manager offers pre-built roles based on common job roles. Choose from three personas: data scientists, MLOps, and SageMaker compute roles. Each persona has predefined permissions tailored to typical actions in the SageMaker console. You can customize these roles by adding or removing permissions. For instance, limit Amazon S3 access to specific buckets. Role Manager integrates with Identity and Access Management or IAM, allowing you to add additional IAM policies during role creation. Create custom personas to fit unique use cases, combining necessary permissions. SageMaker Role Manager streamlines onboarding, making it easier to manage access to SageMaker resources. This tool aids in developing a robust machine learning governance strategy by controlling access to your models. With SageMaker Role Manager, you are one step closer to efficient ML governance. Amazon SageMaker model cards offer a centralized way to document essential details about your machine learning models. They streamline the process of tracking and managing model information. With SageMaker model cards, you can document training details such as datasets, hyperparameters, and algorithms. They also allow you to specify the model's purpose, use cases, and risk ratings. Integrated within the SageMaker console, they auto-populate some training details, simplifying documentation. Model cards help engineers and stakeholders understand model risks and performance issues. They ensure that all relevant information is easily accessible, reducing the risk of data loss across multiple tools. Versioning ensures immutability, creating a new version with each update. These cards are particularly useful for high-risk models like those used in fraud detection. They provide clarity on business impacts and responsibilities, detailing model owners and stakeholders. This is crucial for models with significant business implications. Amazon SageMaker model cards enhance collaboration by exporting to PDF for easy sharing. They ensure everyone knows the model's purpose, usage, and potential issues. Embrace model cards for efficient model management and clear communication. Amazon SageMaker Model Dashboard is your go-to tool for monitoring and auditing deployed machine learning models. It provides a centralized view of all your models, offering a high-level overview and detailed insights into each model's status and performance. With SageMaker Model Dashboard, you can set up alerts to track model behavior. This ensures your models aren't drifting from their initial state or producing biased outputs. The dashboard visually lists models, detailing risk ratings, endpoints, and batch transform job history. Amazon SageMaker Model Monitor offers 4 types of monitors: model quality, data quality, bias drift, and feature attribution drift. These monitors help ensure your model's accuracy, detect data quality issues, identify bias, and track changes in feature attribution values, providing crucial insights. Each monitor's status is displayed on the dashboard. It can be none, inactive, OK, or show the last alert time. This helps you quickly assess the health and performance of your models and take necessary actions when needed. In summary, Amazon SageMaker Model Dashboard is an essential tool for maintaining model quality, accuracy, and fairness. It keeps you informed and ready to address any issues. When working with machine learning models, sharing assets between teams is crucial. Amazon SageMaker Assets allows you to share both data-related and machine learning-related assets seamlessly. Data-related assets might include data tables in AWS Glue or Amazon Redshift, while machine learning-related assets could be SageMaker model groups or feature store feature groups. SageMaker Assets uses Amazon Data Zone, which requires setting up a domain to organize your assets, users, and projects. To share data or models, create a project and corresponding assets. You can publish these assets to team members or make them visible across your organization. To access assets owned by others, submit a subscription request. Asset owners can approve or reject these requests. Once subscribed, any updates to the data or model are automatically visible to subscribers. You can revoke access or unpublish an asset at any time, maintaining control over your shared resources. SageMaker Assets simplifies sharing data and models, empowering team members and stakeholders. It reduces administrative burdens and provides flexibility in managing machine learning assets. Amazon Comprehend is a machine learning service from Amazon Web Services, designed to extract insights from text using natural language processing. It helps businesses understand documents by identifying key phrases, entities, sentiment, and more. NLP is a field combining linguistics, computer science, and artificial intelligence. It enables computers to understand human language, including context and nuances, allowing for efficient analysis of large text volumes. Amazon Comprehend identifies key phrases, entities, and sentiment in text. It assigns confidence scores to these elements, helping businesses make informed decisions. It also detects personally identifiable information and can redact sensitive data to enhance security. Businesses can use Amazon Comprehend to improve customer experiences by analyzing feedback for sentiment. It can also categorize documents by topics, aiding in organization and strategic planning. Its ability to process multiple languages broadens its applicability. In summary, Amazon Comprehend is a powerful NLP tool that leverages machine learning to provide valuable insights from text. It supports various document formats, making it versatile for different business needs. Amazon Comprehend offers 3 processing models. First, single document processing is asynchronous, ideal for analyzing one document at a time. It supports operations like detect dominant language, detect entities, and detect sentiment, delivering results directly to your application. Next, multi-document synchronous processing is for analyzing up to 25 documents simultaneously. Using batch operations like batch detect entities and batch detect sentiment, each document is processed individually, providing separate results. This method enhances performance when dealing with multiple documents. For large documents or quantities, asynchronous batch processing is recommended. It supports additional operations like start topics detection job. Source data must be in Amazon S3 within the same region and in UTF-8 format. This model is optimal for extensive text analysis. Amazon Comprehend requires access to your Amazon S3 bucket, needing permissions via roles. You can create a new role or use an existing one with the correct permissions during your asynchronous batch processing job setup. Choosing the right processing model depends on your document volume and analysis needs. Whether it's single, multi, or batch processing, Amazon Comprehend provides flexible solutions for extracting valuable insights from your text data. Amazon Comprehend Custom lets you tailor text analysis to your business needs. By creating machine learning models, you can detect specific terms like customer numbers, enhancing your organization's data processing capabilities. With Amazon Comprehend's APIs, integrating advanced text analysis into your applications is straightforward. This flexibility means you don't need a text analysis specialist, making it accessible for any team. Amazon Comprehend seamlessly integrates with other AWS services. It works with AWS Lambda for serverless processing, Amazon S3 for storage, and AWS Key Management Service for encryption, ensuring efficient data handling. Security is paramount with Amazon Comprehend. It uses AWS Identity and Access Management for access control and AWS Key Management Service for encryption, safeguarding sensitive data, including personally identifiable information. Amazon Comprehend can analyze millions of documents, offering valuable insights. This scalability allows businesses to quickly respond to customer sentiment, turning potential negatives into positives. Amazon Comprehend's machine learning models are continuously trained with global data, ensuring high accuracy. This ongoing improvement enhances the service's effectiveness over time. Amazon Comprehend medical extracts medical attributes from unstructured text, identifying medications, conditions, and more. It aids in faster diagnosis and treatment decisions, improving patient outcomes. Amazon Comprehend offers customizable, secure, and scalable text analysis solutions. Its integration with AWS services and continuous learning models make it a powerful tool for businesses and healthcare alike. Amazon Polly is a cloud-based text-to-speech service that transforms text into lifelike speech. It's designed for developers aiming to enhance accessibility and engagement in applications, websites, and services with natural-sounding voice experiences. Using Amazon Polly, developers can integrate advanced text-to-speech capabilities, making applications more accessible and engaging. It offers a seamless way to create natural-sounding speech, enhancing user interaction and providing a more inclusive experience for all users. Amazon Polly offers a variety of voice types, including neural, long-form, and generative voices. These options allow developers to choose the most suitable voice for their application, ensuring a personalized and dynamic user experience. With speech synthesis markup language, developers can customize speech output. This includes adjusting pitch, speed, and pronunciation, allowing for a tailored and precise audio experience that meets specific application needs. To secure and monitor Amazon Polly usage, follow best practices within your AWS environment. Feedback is crucial for improvement. If you have any comments, please contact support at Cloud Academy. Your insights help enhance future lessons and services. Text-to-speech technology transforms written text into spoken words, allowing computers to read aloud. This innovation opens up new ways to interact with applications and access information, especially for those who cannot read on screens. Over the years, text-to-speech has evolved significantly. With deep learning, it now produces natural-sounding speech, incorporating pitch, pronunciation, and inflection changes. This advancement has made computer-generated speech an integral part of modern user interfaces. Text-to-speech is widely used in e-learning platforms, personal assistants, and Internet of Things devices. It converts learning content into practical formats and is cost-effective for multilingual customer service, enhancing call center applications with natural voices. In e-learning, text-to-speech enhances learning by providing both visual and audio presentations. This dual mode improves comprehension, recall, vocabulary skills, motivation, and confidence, making it an effective tool for studying, including for Amazon Web certifications. Text-to-speech offers mobility by turning digital content into multimedia experiences. It allows users to listen to news, blogs, articles, or PDFs on the go, providing a convenient way to access information while multitasking. Amazon Polly is a cloud-based text-to-speech service that transforms written text into lifelike speech. Polly supports numerous languages and offers a diverse selection of natural-sounding voices. It includes generative long-form neural and standard text-to-speech voices using advanced machine learning for human-like speech. The neural text-to-speech technology even features a newscaster style for news narration. Amazon Polly is widely used in mobile apps, e-learning platforms, and accessibility tools for visually impaired individuals. For instance, a newsreader app might use Polly to convert articles into spoken words, allowing users to listen on the go. Imagine developing an e-learning platform on cloud engineering. Convert text-based lessons into audio using Amazon Polly. Use a Python script to generate audio files, store them in Amazon S3, and manage them with Amazon DynamoDB. Serve the content via Amazon CloudFront for low latency and high speed, embedding audio into your platform. Amazon Polly enhances applications by providing high-quality, natural-sounding voiceovers, making content more engaging and accessible. Whether for news, education, or accessibility, Polly transforms text into an immersive audio experience. Amazon Polly is a powerful tool for transforming text into lifelike speech. Let's explore how you can get started with it using various methods. The AWS Software Development Kit or SDK is a recommended way to integrate Amazon Polly into your applications. It simplifies creating a Polly client, sending text synthesis requests, and handling audio streams. This approach is ideal for developing e-learning platforms or customer service applications, enabling seamless, high-quality speech generation. For a code-free experience, use the Amazon Polly console. Simply select an engine type like Neural or Standard, choose your language and voice, and listen to your synthesized speech. This user-friendly interface makes it easy to explore Polly's capabilities without any programming. The AWS command line interface offers another way to interact with Amazon Polly. After configuring the command line interface, you can synthesize text into audio files. While you can't listen directly, you can save the output and play it with your preferred audio application. Whether using the AWS SDK, console, or command line interface, Amazon Polly enhances your applications with natural sounding speech. Start integrating today to make your software more interactive and accessible. Amazon Polly offers a diverse range of lifelike voices across multiple languages, including Arabic, Chinese, Danish, Dutch, and English. Each voice is tailored for accurate pronunciation and natural intonation, ensuring high-quality speech synthesis for global applications. Voice speed varies naturally among Amazon Polly voices. For instance, Ivy and Zoan in US English are faster than Matthew and Zoe. You can adjust speed using speech synthesis markup language, tags choosing preset speeds, or setting a custom percentage. Amazon Polly's brand voice feature allows the creation of custom voices that embody your brand's persona. Collaborating with Amazon Polly's AI experts, you can develop unique neural text-to-speech voices. For example, KFC Canada created a Southern US English voice for Colonel Sanders, enhancing their Alexa skill. Neural voices in Amazon Polly can be trained for specific speaking styles, unlike standard voices. This includes mimicking TV or radio newscasters, providing variations and emphasis on speech. These neural voices offer a natural and engaging experience suitable for diverse applications. Amazon Polly offers a variety of voice engines to create lifelike audio. From standard to neural, long-form, and generative voices, each engine provides unique features for diverse applications. The standard engine uses concatenative synthesis, piecing together recorded phonemes to form speech. This method ensures natural sound by using actual human recordings. Amazon Polly offers 40 female and 20 male voices in 29 languages. Amazon Polly's neural text-to-speech engine enhances speech quality. It uses neural networks to convert phonemes into spectrograms, which are then transformed into audio by a vocoder. This results in more natural-sounding voices available in 33 languages. The long-form engine excels in creating expressive voices for extended content like news articles. It uses deep learning to replicate human speech nuances, including prosody and intonation. Voices like Ruth and Grigory offer engaging audio experiences. The generative engine provides the most human-like voices using a billion-parameter transformer. It converts text into speech codes, creating adaptive conversational voices. Ideal for virtual trainers, voices like Matthew and Ruth deliver realistic audio experiences. Explore how to enhance speech with Amazon Polly using speech synthesis markup language or SSML. This XML-based language lets you control pronunciation, volume, pitch, and speed for more natural and expressive audio. SSML offers flexibility in speech synthesis. By adding SSML tags to your text, you can instruct Amazon Polly to include pauses, adjust speech rate or pitch, and even add whispering effects. Enter your SSML enhanced text in the AWS Management Console. The prosody element in SSML allows you to adjust volume, pitch, and speed. Combine these attributes for a dynamic effect. To mimic natural speech, add breathing sounds with Amazon Breathe tags or use the Amazon Effect Whispered element for whispers. Use the emphasis element to highlight specific words, making them stand out. The C as element helps format text like dates or numbers, ensuring correct pronunciation. The Interpret as attribute provides context for accurate speech output. With SSML, Create engaging and tailored speech output using Amazon Polly. Customize your audio to sound natural and dynamic, enhancing the listener's experience with precise control over speech elements. Ensuring the security of your data with Amazon Polly involves following key best practices. These steps help protect your AWS resources and sensitive information. Amazon Polly operates under the AWS Shared Responsibility model. AWS secures the global infrastructure, while customers protect personal data they upload to the cloud. Protect your AWS account credentials and use AWS Identity and Access Management to set up individual users. Assign permissions based on roles and enable multi-factor authentication for added security. Use Secure Sockets Layer or SSL and Transport Layer Security or TLS to encrypt data in transit. Monitor Amazon Polly API calls with AWS CloudTrail and track job status using Amazon CloudWatch logs. AWS CloudTrail logs all API calls to Amazon Polly, providing insights into activities within your AWS environment. This audit trail helps maintain visibility and control over your resources. For enhanced security, use Amazon Virtual Private Cloud or VPC to create a private connection to Amazon Polly. This setup allows speech synthesis without using the public internet, ensuring secure data handling. Amazon Transcribe is a fully managed service from Amazon Web Services or AWS, offering automatic speech recognition capabilities. It converts speech into text with remarkable accuracy and efficiency. Amazon Transcribe supports dozens of languages and dialects, handling variations in volume, pitch, and speaking rate. It provides timestamps and confidence scores for each word, identifies separate audio channels, and labels multiple speakers. It can redact personally identifiable information and detect toxic content. Transcribe supports both batch and real-time processing, accommodating various audio formats. Transcribing audio to text unlocks significant value. It enables adding subtitles for the hearing impaired, performing real-time translations, and creating searchable archives. It's useful across industries, from media to healthcare, enhancing accessibility and data management. Amazon Transcribe allows custom vocabularies and vocabulary filters to improve transcription accuracy. For complex language patterns, users can create custom language models or CLMs using domain-specific tests to enhance precision. Amazon Transcribe uses a pay-as-you-go model, charging per minute of transcribed audio. The tiered pricing reduces costs as usage increases. Additional charges apply for features like content redaction and toxicity detection. Imagine you have a single audio file in an Amazon S3 bucket. With Amazon Transcribe, you can create a transcription job to convert this audio into text, storing it back in S3. For large audio or video archives, like a podcast library, Amazon Transcribe can generate transcripts stored in S3. These can be indexed using Amazon Kendra, making spoken words easily searchable. Amazon Transcribe, combined with Amazon Translate and Amazon Polly, enables real-time translation. As one person speaks, Transcribe converts speech to text, Translate translates it, and Polly vocalizes it, facilitating multilingual conversations. In call centers, Amazon Transcribe processes customer support calls. The text output is analyzed by Amazon Comprehend, extracting insights like key phrases and sentiment, enhancing agent training and customer service. Amazon Transcribe offers specialized services like call analytics, providing call summaries and sentiment analysis, and Transcribe Medical, accurately transcribing medical terms. AWS HealthScribe generates clinical notes from patient-clinician interactions, ensuring privacy by not retaining audio or text. Discover how Amazon Transcribe transforms speech into text effortlessly. Navigate the AWS console, select Transcribe, and explore specialized features like call analytics and Transcribe Medical. Creating a real-time transcript is simple. Click Create a transcript, then start streaming. Speak into your microphone and watch your words appear instantly. Adjust your speaking rate, volume, or pitch and finish by clicking Stop Streaming. Amazon Transcribe offers flexible language settings. Choose a specific language or enable automatic identification for multiple languages. Audio settings allow speaker partitioning, separating speech from up to 10 speakers. Enhance privacy with vocabulary filtering and PII identification. Choose to identify or redact personal information like names and financial details. Customize further with custom vocabularies and partial result stabilization for accuracy. Balance stability and accuracy with partial result stabilization settings. Use custom language models for tailored transcription. Integrate with applications using example API requests for real-time transcription via HTTP2. Amazon Transcribe simplifies speech-to-text conversion, offering powerful tools for diverse needs. Amazon Translate is a neural machine translation service from Amazon Web Services or AWS that translate text between 75 languages. It uses deep learning models for natural accurate translations. Amazon Translate supports real-time and asynchronous batch processing. Real-time is perfect for quick translations of text files, HTML, or Microsoft Word documents. Batch processing handles larger volumes up to 5 GB, including Excel and PowerPoint files. Amazon Translate can detect source languages using Amazon Comprehend. It offers do not translate tags for text you want to keep unchanged and profanity masking to replace offensive words with symbols. Amazon Translate provides brevity for concise translations and formality control for choosing between formal or informal language. Custom terminology and parallel data adaptation allow for specific word or phrase translations useful in specialized fields like law or medicine. Amazon Translate enables multilingual experiences by translating websites and data. It can translate document repositories stored in AWS services. Developers can integrate translation into applications and combine it with services like Amazon Transcribe for real-time spoken translations. Discover how to use Amazon Translate for real-time text translation. Navigate to the AWS console, search for Translate, and click the button to start translating instantly. Choose between text or document translation. For text, select your source language or leave it as auto-detect. Pick a target language like French and type your text. Watch as Amazon Translate detects the source language and provides a translated version instantly. Explore additional settings to refine your translation. Toggle brevity to shorten text or adjust formality for a formal or informal tone. These features depend on the target language's capabilities. For larger documents, use batch translation. Create a job, name it, and select source and target languages. Point to an S3 bucket for input and output and specify file formats like plain text or HTML. Define custom terminology for specific translations useful for brand names. Use parallel data for phrase-level translations, ensuring consistent style or tone. Set permissions with an IAM rule to manage input and output buckets. Amazon Recognition is a powerful service that leverages generative AI to analyze images and videos. It enables developers to integrate advanced visual analysis into their applications, enhancing capabilities for software developers, data scientists, and IT professionals. Recognition offers features like facial analysis, object detection, and scene recognition. It's ideal for applications in security, media, and retail. By understanding these features, developers can create innovative solutions tailored to specific industry needs. Developers can interact with recognition through APIs, the AWS Management Console, command line interface, and software development kits. This flexibility allows seamless integration into existing workflows, making it accessible for various technical backgrounds. Implementing best practices ensures efficient use of recognition. Combining it with AWS services like Lambda, S3, and DynamoDB can create a serverless image analysis solution. Familiarity with Python programming enhances this integration process. Understanding Amazon Recognition's capabilities empowers developers to build advanced applications. Amazon Recognition is a powerful image and video analysis service from the Amazon AI family. It leverages deep learning technology, a branch of machine learning that mimics the brain's neural networks to identify patterns and make decisions with minimal human intervention. Recognition Image offers advanced capabilities to search, verify, and organize millions of images. It detects objects, scenes, activities, landmarks, faces, colors, and image quality. This service can also recognize celebrities and extract text, handling various fonts and orientations. Recognition Image is invaluable for tagging and organizing digital libraries, confirming user identities through facial comparison, and ensuring content safety by filtering explicit material. It also identifies celebrities and extracts text for visual searches or metadata purposes. Recognition Video analyzes both stored and live stream videos. It detects activities, tracks people, and recognizes objects, celebrities, and content. The service indexes video metadata, making it easy to search for specific scenes, landmarks, or faces. Recognition Video enables facial search in videos, monitors safety compliance by detecting improper equipment, and extracts text for metadata. It also identifies custom objects and scenes, allowing businesses to train custom labels for niche applications. Explore Amazon Recognition in the AWS Management Console, a user-friendly tool for image and video analysis without coding. Start with label detection. Upload an image or use a sample. Recognition identifies objects like person, skateboard, and city providing confidence scores. This feature helps categorize images based on context, making it a powerful tool for organizing large photo collections. Next, facial analysis. Upload a photo and recognition detects attributes like gender, age, and expressions. For instance, it might identify a person as female, aged 19 to 23, smiling with 99.6% confidence. This detailed analysis aids in security and personalized experience. Recognition also extracts text from images. For example, it can read a car's registration plate. This feature is useful in automated parking systems, traffic management, and digitizing documents. Recognition processes videos, identifying people, celebrities, and objects. It categorizes content, aiding in search and content analysis. The tool can also flag inappropriate content, ensuring safe media consumption. Amazon Recognition offers powerful image and video analysis features through the AWS Management Console. Explore these capabilities to enhance your projects without writing any code. Discover the power of Amazon Recognition, a tool that brings visual analysis to your applications. From identifying celebrities to moderating content, Recognition offers diverse capabilities for image and video analysis. To begin, install the AWS command line interface and configure it with your credentials. For software development kit usage, install the appropriate kit for your programming language like Boto 3 for Python. Ensure you have the necessary permissions to access recognition services. Using the AWS command line interface, you can identify celebrities in images. For example, by uploading an image of Cristiano Ronaldo to an S3 bucket, the Recognize Celebrities API can detect and provide details about him, including confidence scores and relevant URLs. With the Python Software Development Kit, use the Detect Moderation Labels API to ensure content safety. By analyzing an image of a man drinking beer, Recognition flagged it for alcohol use, demonstrating its effectiveness in content moderation. The Detect Faces API analyzes facial attributes like age and emotions. In a demo, it identified multiple faces with detailed attributes, showcasing its utility in security and personalization. Recognition can also detect personal protective equipment, ensuring workplace safety. By analyzing an image, it identified a worker wearing necessary gear, proving its reliability in compliance checks. To minimize latency in Amazon Recognition, ensure your Amazon S3 bucket and Recognition API operations are in the same AWS region. This reduces data transfer time. For near real-time processing, send image bytes directly to Recognition instead of uploading to S3 first. If images are stored in S3, reference them directly in Recognition operations for faster access. Understanding confidence scores is crucial for accurate applications. Recognition scores range from 0 to 100, indicating prediction certainty. Use appropriate similarity thresholds for your use case. Lower thresholds may increase matches but need human review. Higher thresholds offer more confidence but might miss valid matches. Adjust thresholds based on real-world performance to maintain optimal results. Integrate Recognition with other AWS services for enhanced capabilities. Use Amazon S3 for automatic analysis of new uploads. Connect with AWS Lambda to automate image or video analysis. Pair with Amazon Comprehend to analyze visual and text elements. Use Amazon SageMaker for custom AI models, Amazon Kinesis for live video, and Amazon CloudWatch for performance monitoring and alerts. Begin by setting up a DynamoDB table. Name it Image Analysis Results with Object Key as the partition key. This table will store image analysis results efficiently. Next, create a simple notification service or SNS topic named Image Analysis Notifications. Subscribe via email to receive real-time notifications about image analysis results. Create a new Lambda function named Image Analysis. Use Python as the runtime environment. Initially, assign basic permissions which will be expanded to interact with AWS services like Recognition and Comprehend. Customize the Lambda function code. Import necessary libraries and set up connections to AWS services. Modify the code to detect specific objects, store results in DynamoDB, and send notifications via SNS. Create an S3 bucket with a unique name. Enable ACLs and set object writer for ownership. Create an input folder and configure event notifications for JPEG uploads. Test the application with two images. First, upload an airplane image to verify object detection and sentiment analysis. Then, test with an image containing a person and positive text to ensure versatility. Meet Amazon Q, a generative AI-powered assistant unveiled at re:Invent 2023. Designed to revolutionize data interaction, Amazon Q is customizable to fit your business needs, enhancing productivity and efficiency. Amazon Q is not just an expert on AWS services. It generates source code in various languages, connects to corporate data systems, synthesizes data, and tailors interactions based on user roles. Imagine having a powerful assistant that boosts your productivity, allowing you to achieve more in less time. Amazon Q enables the creation of generative AI web applications for conversational interactions. From graphic designers seeking branding guidelines to analysts summarizing meeting notes, Amazon Q provides fast, accurate responses. It even remembers conversation history for seamless follow-ups, making it a versatile tool for diverse tasks. Amazon Q is accessible across multiple platforms, from the AWS console to development environments like Visual Studio Code. It integrates with AWS services such as Amazon QuickSight and Amazon Connect, ensuring it's available wherever work happens. Amazon Q offers endless possibilities for transforming business operations. With its expert capabilities and seamless integration, it stands as a powerful ally in the modern workplace. Amazon Q is a powerful tool for organizations leveraging Amazon Bedrock's diverse foundation models. Unlike ChatGPT, it draws from Amazon Titan on models by Anthropic and Meta, making it ideal for AWS-related queries. One of Amazon's Q standout features is its ability to securely connect to various enterprise systems. It can be trained on your company's data from sources like Amazon S3, SharePoint, and Gmail, ensuring tailored responses. Amazon Q integrates with IAM Identity Center, allowing granular access controls. This ensures sensitive information is only accessible to authorized personnel, maintaining confidentiality and security within your organization. Amazon Q minimizes AI hallucinations by using only your enterprise data for responses. It cites sources for every answer, promoting trust and enabling users to verify and explore information further. Administrators can set guardrails, control chat features, and block specific words or phrases. This customization helps protect your company's reputation and ensures Amazon Q aligns with your organizational standards and policies. Amazon Q is your versatile AWS assistant connecting seamlessly with your company's data. It offers quick, accurate responses to employee inquiries and leverages extensive AWS knowledge, including the well-architected framework and best practices to assist in cloud solutions. Amazon Q excels in AWS guidance, answering questions like how do I build a serverless application or what MySQL versions are supported on Amazon RDS. It recommends optimal EC2 instances and provides detailed answers with citations for further learning. Amazon Q integrates with your AWS account, listing resources like Lambda functions and EC2 instances. It also analyzes cost data through AWS Cost Explorer, offering insights into spending trends and service-specific cost breakdowns, enhancing financial transparency. For developers, Amazon Q offers code analysis, automatic code generation, and feature implementation. It works with IDEs like Visual Studio Code, assisting with legacy code and generating implementation plans, ensuring adherence to AWS best practices. Amazon Q simplifies data management with AWS Glue and Amazon Redshift. It uses natural language prompts for data integration and generates SQL queries, enabling efficient data handling without requiring deep technical knowledge of SQL or data schemas. Amazon Q in QuickSight revolutionizes business intelligence by using natural language to create and enhance dashboards and reports. This generative BI tool allows users to ask questions conversationally, uncovering insights like why sales might have dropped in a specific region. It crafts executive summaries, refining data presentations for diverse stakeholders. With Amazon Q in QuickSight, users can delve into the why behind their data. By simply asking questions, it generates dashboards that provide supporting information, helping businesses understand trends and anomalies. This conversational approach makes data analysis more intuitive and accessible for business users. Amazon Q in Connect transforms customer service by acting as a live assistant for call center agents. It processes real-time conversations, offering response suggestions and actions, reducing call times and boosting customer satisfaction. This tool helps new agents quickly adapt, minimizing the need for supervisor intervention. For supply chain managers, Amazon Q in AWS Supply Chain offers insights into data stored in the AWS Supply Chain Data Lake. It enables exploration of current statuses and potential what-if scenarios, helping mitigate risks and plan for future inventory challenges, ensuring resilience and financial stability. Once logged into your AWS console, find Amazon Q on the right. Click the Q icon to start asking questions. Builders can inquire about AWS services, troubleshooting, and best practices directly within the console. Amazon Q integrates with core AWS services like the EC2 instance type selector. For example, when launching an EC2 instance, Click Get Advice to receive tailored recommendations. Q analyzes your workload needs and suggests instance families like M7G, C07G, and T4G. If cost is a priority, you might choose T4G. Ask Q for instance size recommendations such as T4G.medium for 1000 daily users. Q provides justifications and scaling advice, streamlining your decision-making process. Beyond instance types, Q offers guidance on AWS best practices. For instance, ask how to create a serverless CRUD application, and Q will outline the necessary services and steps enhancing your architectural planning. Whenever you encounter a red error or informational pop-up, Amazon Q can help you understand and resolve the issue. Simply open the Q chat window in the AWS console and type your question for detailed insights. For instance, if you see an access denied error under the cost and usage panel, ask Q, why am I getting an access denied error? Q will provide information on the error and troubleshooting advice. In some AWS services, a Troubleshoot with Amazon Q button appears when errors occur. For example, in AWS Lambda, if a function lacks permissions, clicking this button prompts Q to analyze and suggest solutions like updating permissions. If issues persist, Amazon Q can help you contact AWS support. Simply type, I want to speak to someone, or get support to create a support case. Currently, the Troubleshoot with Amazon Q feature supports Amazon EC2, ECS, S3, and Lambda in the US West 2 or Oregon region. Discover how Amazon Q can transform your coding experience within your integrated development environment or IDE. It offers seamless AWS guidance, code explanations, optimizations, and more, all without leaving your workspace. To start using Amazon Q, install the AWS Toolkit extension for Visual Studio Code or JetBrains IDEs. Authenticate your AWS credentials by signing in with your AWS Builder ID. Click on the AWS Toolkit tab, find the Q label, and follow the prompts to sign in and grant necessary permissions. Once set up, click the Amazon Q icon in your IDE to open a chat window. Here, you can ask questions like generate code to interact with S3 in Python. Q provides the correct syntax, which you can insert directly into your code. Use upvote or downvote options to improve response accuracy. Amazon Q also helps optimize existing code. For instance, if you hardcode AWS credentials, Q suggests alternatives like using environment variables. This ensures your code follows AWS best practices and enhances security, performance, and readability. Let's explore how Amazon Q commands can enhance your coding experience. Start with the basics. The clear command refreshes your chat window, while help provides guidance on Amazon Q's capabilities and limitations. These commands ensure a smooth interaction with the Amazon Q. For advanced users with a Code Whisperer professional license, Amazon Q offers powerful commands. Amazon Code Whisperer is a machine learning coding assistant that generates code snippets in your integrated development environment or IDE. The transform command is a game changer for upgrading your codebase. It identifies deprecated code, updates dependencies, and creates tests for a seamless transition to newer versions, saving developers significant time. The dev command simplifies feature development. By describing your needs in plain English, Amazon Q analyzes your project and creates an implementation plan. Once approved, it updates your codebase, adding necessary files and functions. These commands, clear, help, def, and transform, are essential for maximizing Amazon Q's potential. These streamline interactions and enhance coding efficiency, empowering developers to focus on innovation. Amazon Q seamlessly integrates with AWS Glue, simplifying data integration tasks. AWS Glue, a complex service, now offers a chat interface powered by Amazon Q. This feature acts like a built-in expert, providing guidance and generating code. Users can ask questions, troubleshoot errors, and optimize scripts in plain English. For instance, Q can help write an extract, transform, load script to move data from S3 to DynamoDB. Amazon Q also enhances the Redshift query editor experience. By using Q Generative SQL, users can input queries in natural language. For example, typing "find the total sum of all orders from this customer ID" prompts Q to generate the necessary SQL code. This tool leverages Q history and database schema to produce accurate results, reducing the need for extensive SQL knowledge and boosting productivity. Amazon Q's integration with AWS Glue and Redshift revolutionizes data management. By offering expert guidance and code generation, it reduces the need for deep technical expertise. Users can focus on their data needs without getting bogged down in complex coding. This innovation not only enhances efficiency, but also empowers users to achieve more with less effort. Amazon Code Catalyst is a comprehensive software development service. Integrating Amazon Q enhances productivity by streamlining the development lifecycle with 3 key features. Amazon Q can automatically generate pull request summaries in Code Catalyst. It analyzes both the source and destination branches to provide a detailed description of changes and their intended purposes. Q also summarizes comments on pull requests. It identifies common suggestions from feedback, helping developers quickly understand necessary fixes or additions. Note that these summaries are temporary and disappear upon refreshing or deleting the pull request. Development teams can assign issues to Amazon Q. Once assigned, Q attempts to create solutions, addressing issues that might otherwise remain unresolved due to time or resource constraints. To configure Q, decide on feedback levels, whether it can update workflow files, and which repository it should work in. Q then drafts a solution, comments on progress, and creates a pull request for review. Integrating Amazon Q with Code Catalyst boosts productivity and streamlines workflows, offering valuable assistance throughout the software development process. Explore these features to enhance your development experience. Deep learning, a branch of machine learning, mimics the human brain's neural networks to solve complex problems. It uses artificial neural networks to analyze data, identifying patterns across images, text, and sounds, enabling precise predictions and insights. Deep learning automates tasks requiring human intelligence, such as image description and fraud detection. It's integral to AI features in devices like voice-controlled assistants and facial recognition, advancing technologies like autonomous vehicles and virtual reality. Deep learning applications fall into four categories: natural language processing, computer vision, speech recognition, and recommendation engines. These technologies power chatbots, content moderation, real-time speech translation, and personalized recommendations like Netflix video suggestions. AWS accelerates deep learning by providing scalable services to build, train, and deploy neural networks. Leveraging GPUs and accelerators, AWS enables faster training of complex models, handling large datasets with unlimited compute and storage capabilities. AWS offers services like Amazon SageMaker, Recognition, Transcribe, and Lex. These tools simplify deep learning processes from data preparation to model deployment. AWS Deep Learning AMIs support frameworks like TensorFlow and PyTorch, facilitating experimentation and innovation. AWS Deep Learning Amazon Machine Images or AMIs offer pre-installed deep learning frameworks like TensorFlow and PyTorch. These ready-to-use images save time by including Python packages and dependencies, allowing users to quickly start deep learning projects without configuration hassles. Conda-based AMIs provide pre-installed environments for frameworks like MXNet and TensorFlow 2, ideal for those seeking convenience. The base AMI offers a foundational setup with NVIDIA drivers, allowing users to customize their software stack and choose specific framework versions. Single framework AMIs focus on one deep learning framework such as TensorFlow or PyTorch. They come pre-configured, letting users concentrate on their chosen framework. Essential Python libraries and utilities like Jupyter Notebook are included for seamless model prototyping and visualization. Selecting the right EC2 instance is crucial. GP2 instances are recommended for faster model training, while CPU instances suit budget-conscious users. AWS Trainium and Inferentia chips enhance performance for large-scale applications like natural language processing and fraud detection. AWS Deep Learning containers are Docker images optimized for machine learning. They support frameworks like TensorFlow and PyTorch, ensuring consistent environments across AWS services. These containers streamline model deployment, benefiting from AWS Neuron SDK for enhanced performance. AWS Neuron is a software development kit designed to optimize machine learning workloads on AWS custom chips, Trainium, and Inferentia. It enhances performance and cost effectiveness for deep learning tasks. The Neuron SDK includes a compiler, runtime, and profiling tools. These components work together to unlock high-performance deep learning acceleration, ensuring models run efficiently on AWS hardware. The compiler prepares machine learning models for Inferentia accelerators by analyzing and transforming them into a format that maximizes performance. This process involves merging redundant operations and compiling the model graph into optimized binary executables. For training, the SDK uses Neural Parallel Compile to optimize common computation graphs. Just-in-time compilation handles new graphs, ensuring smooth training. Static batch sizes prevent recompilation, enhancing efficiency across multiple accelerators. Neuron SDK supports TensorFlow and PyTorch, allowing seamless integration with existing workflows. It includes profiling tools like TensorBoard for performance insights. The SDK integrates with AWS services such as deep learning AMIs and containers, enabling easy deployment on EC2 instances with Trainium and Inferentia chips. AWS Neuron SDK offers command line tools to optimize machine learning workloads on AWS hardware. These tools streamline compiling, optimizing, and deploying models on Neuron devices like Trainium and Inferentia. The Neuron SDK includes tools like Neuron Compile, Neuron Optimize, and Neuron Runtime for model deployment. Analysis tools such as Neuron Monitor, Neuron Profile, and Neuron Report evaluate performance, while Neuron Top and Neuron Wiz provides insights into resource usage. Neuron Compile converts models from frameworks like TensorFlow and PyTorch into an intermediate representation for Neuron Runtime. Neuron Optimize enhances compiled models' performance on Neuron devices, ensuring efficient execution. Neuron Runtime manages model execution on Neuron hardware, optimizing inference tasks. Neuron Monitor collects real-time metrics from Neuron runtimes, integrating with systems like CloudWatch and Prometheus for performance tracking. Neuron Profiler identifies optimization opportunities by collecting timing and memory data. Neuron Report generates detailed profiling reports highlighting bottlenecks and computationally intensive operations for further optimization. Neuron Wiz visualizes model computation graphs, showcasing optimizations and memory allocation plans. It helps compare computational graphs before and after optimization, facilitating enhanced execution on Neuron devices. Amazon CloudWatch is your window into the health and performance of your applications and infrastructure. It collects operational data, enabling you to monitor and optimize your resources effectively. CloudWatch offers a range of features like dashboards, metrics, alarms, event bridge, and logs. These tools provide insights and automate responses, helping minimize incidents and optimize performance. With CloudWatch dashboards, you can create customized views using visual widgets. These dashboards offer a unified view of metrics and alarms tailored to your business needs and can be shared with others. Metrics track specific elements of resources over time. CloudWatch alarms use these metrics to trigger actions based on thresholds. For instance, alarms can autoscale resources or notify engineers of changes. CloudWatch Event Bridge connects applications to AWS services for real-time monitoring. It uses rules, targets, and event buses to manage event traffic. CloudWatch logs centralized log data, and Log Insights analyze logs in real time, offering valuable insights into your applications. AWS CloudTrail is a powerful service designed to record and track all AWS API requests. Whether initiated by users, other AWS services, or the AWS Management Console, CloudTrail captures it all. When an API request occurs, CloudTrail logs it as an event, storing it in a log file on Amazon S3. Each event includes metadata like the caller's identity, timestamp, and source IP address. New log files are created every 5 minutes, ensuring a comprehensive history of API requests. CloudTrail supports over 60 AWS services globally, capturing extensive data across multi-region infrastructures. Logs can also be sent to CloudWatch logs, enabling custom metrics and alerts through the Simple Notification Service or SNS for security monitoring. CloudTrail is invaluable for security analysis, identifying malicious activity, and implementing controls. It also aids in resolving operational issues by tracking API calls, helping quickly identify root causes and prevent future incidents. For governance, CloudTrail provides essential log files for compliance, capturing API calls and changes to resources. This ensures you can meet certification requirements by recalling specific changes, enhancing your AWS environment security and governance. AWS CloudTrail is a powerful tool for tracking and monitoring API calls. Let's explore its features and components. Trails are the foundation of CloudTrail, capturing API requests. Logs record these events every 5 minutes, stored in Amazon Simple Storage Service or S3. Event selectors customize which API requests are captured, while tags add metadata to trails. Amazon Web Services Key Management Service or KMS offers optional encryption for log files in S3. Simple Notification Service or SNS can notify teams when new logs arrive. CloudWatch logs provide additional monitoring, delivering logs to AWS CloudWatch for metric analysis. Creating a trial involves specifying an S3 bucket for log storage. You can enable KMS for encryption and SNS for notifications. Log file validation ensures data integrity. Once created, configure CloudWatch logs and event selectors for tailored monitoring and tagging. When an API call matches a trail, it's recorded as an event. These events are stored in S3 and possibly CloudWatch logs, depending on configuration. CloudStreet components work together to provide a comprehensive API tracking solution, ensuring security and monitoring across your AWS environment. AWS Config is a powerful tool designed to simplify resource management in the cloud. It helps organizations track and manage their IT infrastructure by capturing resource changes and configurations. AWS Config records changes to resources, storing them as configuration items or CIs. It acts as a resource inventory, discovering supported resources and storing their configuration history. This service provides snapshots of current configurations and uses the Simple Notification Service or SNS to notify users of changes. AWS Config integrates with AWS CloudTrail to identify who made changes and when. It enforces compliance by allowing predefined and custom rules to check resources against specific controls. This ensures that your infrastructure meets internal and external governance requirements. AWS Config aids in security analysis by recording security-related resources and applying rules like encryption checks. It also provides relationship connectivity information, showing how resources are linked, such as which EC2 instance an EBS volume is connected to. AWS Config is region-specific, requiring configuration for each region. You can customize settings per region, such as recording all resources or focusing on specific types like security groups. Global services like IAM can also be included. AWS Config is a service that helps you manage and monitor your AWS resources. Understanding its components is crucial for maximizing its potential and ensuring compliance with your configurations. The main components include AWS resources, configuration items, configuration streams, configuration history, configuration snapshots, configuration recorder, config rules, resource relationships, simple notification service topics, S3 buckets, and AWS config permissions. Configuration items or CIs are JSON files capturing configuration details and relationships of resources. They are created whenever a resource changes and are sent to configuration streams for analysis. Configuration history uses CIs to track changes over time, accessible via the AWS Management Console or command line interface. Snapshots provide a point-in view of all resources stored in S3 buckets. Config rules, often Lambda functions, evaluate resource compliance. If a rule is violated, AWS config marks the resource as non-compliant and sends a notification allowing you to take corrective action. AWS config maps resource relationships, aiding troubleshooting. Notifications and data are sent via simple notification service and stored in S3 using AWS config's delivery channel for seamless integration. In today's digital age, data security is paramount. Amazon Macy is your ally in safeguarding sensitive information. It helps prevent data leaks by automating the discovery of vulnerabilities in your Amazon S3 buckets. Amazon Macy uses machine learning to identify sensitive data like personally identifiable information and financial details. It provides detailed reports and take actions using services like Lambda and step functions. Macy creates a service-linked rule to access your S3 buckets, generating metadata and monitoring for changes. It evaluates security access controls and detects sensitive data, ensuring constant visibility into your data security. Macy runs sensitive data discovery jobs, analyzing objects for financial, personal, and medical information. It uses managed and custom data identifiers to detect specific data types, helping automate workflows and suppress clear findings. Macy supports various encryption types and file formats, including text, document, and compressed files. It analyzes encrypted objects using service-linked rule, ensuring comprehensive data protection. Amazon Macy charges for bucket protection and data discovery jobs. While costs can add up, it's a worthwhile investment to avoid the repercussions of a data breach. AWS Private Link is a powerful service that facilitates secure and private connections between AWS-based service providers and their consumers. It leverages the AWS global network, bypassing the public internet to ensure data privacy and security. AWS Private Link involves two main entities: service providers and service consumers. Service providers offer endpoint services, while service consumers access these services. Importantly, connections can only be initiated by the consumer, protecting them from unsolicited communications from providers. AWS Private Link is versatile, with three primary use cases. First, it allows customers to access services from AWS partners like Datadog and Salesforce without public internet exposure. Second, it helps maintain regulatory compliance by keeping sensitive data off the public internet. AWS Private Link can be used as a means to maintain regulatory compliance by keeping sensitive data from traversing the public internet. Lastly, it supports hybrid cloud migrations by enabling on-premises resources to connect to AWS service endpoints via AWS Direct Connect or VPN. This ensures a seamless integration and enhanced security for businesses. To set up AWS Private Link, service providers deploy necessary AWS resources for their services. They use a network or gateway load balancer to front-end these services. Once validated, a private link service endpoint is created, granting access to specific AWS principals. On the consumer side, a virtual private cloud or VPC endpoint is established to connect to the provider's service. Providers can enable or disable acceptance for endpoint connections and configure private DNS name settings for seamless integration. Service providers control access using permissions and acceptance settings. They assign permissions to AWS accounts, identity and access management users, or roles. If acceptance is required, providers must manually approve connection requests, ensuring secure access to their private link services. Private DNS names allow consumers to connect using custom, user-friendly domain names. Providers specify their preferred fully qualified domain name when creating the endpoint. Consumers enable this option to use the specified private DNS names, simplifying service connections without needing a root 53 private hosted zone. AWS Private Link enables secure and private access to services from on-premises users or applications. It can be accessed via AWS Direct Connect or VPN connections, ensuring seamless integration with your existing infrastructure. To access private link services from multiple virtual private clouds across regions, deploy a private link endpoint in each VPC or use a centralized AWS account as a network hub. VPC peering connections facilitate access to private link resources. Be aware of AWS service quotas when using private link. By default, 50 interface and gateway load balancer endpoints are allowed per VPC, but this can be adjusted. Similarly, 20 gateway VPC endpoints are permitted per region with adjustable limits. CloudWatch provides metrics for private link endpoints at no extra cost. Metrics like active connection, bytes processed, and packets dropped help monitor performance and costs. An increase in RST packets received may indicate issues with the endpoint service provider. AWS Private Link offers secure, scalable, and monitored access to services. Understanding its deployment options and quotas ensures optimal performance and integration with your network infrastructure. Amazon Inspector is a powerful tool for automated and continuous vulnerability management at scale. The latest version enhances its capabilities, making it essential for scanning Amazon EC2 instances, Elastic Container Registries, and Lambda functions for vulnerabilities. The AWS Shared Responsibility Model outlines security responsibilities between AWS and customers. While AWS secures the infrastructure, customers must manage operating system updates, patches, and the security of their EC2 instances. Amazon Inspector version 2 offers improved automation and integration with other AWS security services. It continuously scans for software vulnerabilities and unintended network exposure, ensuring your cloud resources remain secure and compliant. Amazon Inspector has evolved into a new version, replacing the previous Inspector Classic. This updated tool automates security scans for applications, identifying unintended network exposure, vulnerabilities, and deviations from best practices, ensuring your applications remain secure. The new Amazon Inspector offers automated discovery and continuous scanning, providing near real-time results. These results are presented as findings with a meaningful risk score. Supported by a vulnerability database maintained by AWS security experts, it includes steps for remediation, enhancing your security posture. Amazon Inspector can be enabled at the organization level for multi-account management. It scans EC2 instances, elastic container registries, and Lambda functions. Inspector findings can be integrated with AWS Security Hub, Amazon Event Bridge, or solutions from Amazon Partner Network partners, streamlining security workflows. Inspector findings are accessible via the Inspector console and can be dispatched to various platforms for further action. These findings help implement workflows for issue resolution and remediation, ensuring that security vulnerabilities are addressed promptly and efficiently, maintaining the integrity of your applications. Amazon Inspector now uses the AWS Systems Manager agent instead of its own dedicated agent. This consolidation simplifies provisioning and enhances performance. The agent is pre-installed on some AWS Amazon Machine Images or AMIs and supports various operating systems. Gone are the days of manual scheduling and configuration. Amazon Inspector now automatically discovers and continuously scans your resources. This ensures that your environment is always under scrutiny even when changes occur, making security management seamless. Amazon Inspector integrates with AWS organizations for centralized management. It also connects with Amazon Event Bridge and Security Hub for near real-time responses. This integration can trigger remediation workflows, resolving issues faster even with third-party products. Inspector includes a knowledge base with hundreds of security compliance rules. It provides severity scores using the Common Vulnerability Scoring System or CVSS format. This helps identify vulnerable software versions and take necessary mitigation steps promptly. With just a single click, Amazon Inspector can be enabled for an entire organization. New members joining the organization automatically benefit from the service, ensuring consistent security measures across all accounts.
The Amazon Inspector dashboard offers a comprehensive view of security findings across your environment. It highlights scan coverage, critical findings, and resources with the most issues. The risk based redemption panel helps identify and address critical vulnerabilities efficiently. Amazon Inspector categorizes findings as active, suppressed, or closed. Active findings indicate potential security threats needing remediation. Suppressed findings are excluded using rules, while closed findings are automatically marked when resolved. This system ensures efficient management of security issues. Inspector scans Amazon EC2 instances, Elastic Container Registry, and Lambda functions. Container image findings are accessible in the Amazon ECR console. You can view all findings via the AWS command line interface or an API invocation, ensuring comprehensive coverage. Findings can be grouped by vulnerability, account, or instance. This allows you to identify critical issues and vulnerable resources. Suppression rules filter findings without affecting their generation, helping focus on significant threats while managing less critical ones. Inspector exports findings to Event Bridge and optionally to an Amazon S3 bucket. A key management service key is required for encryption and S3 permissions are needed for uploads. This ensures secure and organized storage of security data. AWS Audit Manager simplifies continuous compliance by automating evidence collection for audits. It helps assess risk and compliance with regulatory standards, ensuring your AWS usage aligns with industry requirements. Audit Manager automates evidence collection, creating audit ready reports effortlessly. It supports collaboration between internal audit members, governance, risk management, and compliance teams, as well as IT and security operations teams. Pre-configured frameworks align with regulations like the General Data Protection Regulation and the Center for Internet Security. You can also create custom frameworks to meet specific industry needs using over 600 standard controls. The audit owner manages assessments, delegating tasks to subject matter experts known as delegates. Delegates review specific controls, ensuring evidence is validated and secure, adhering to the principle of least privilege. Start by defining your audit scope and selecting a framework. Specify AWS accounts and services to monitor. Assign an audit owner with the AWS Audit Manager Administrator Access Policy. Once set, Audit Manager continuously monitors your AWS usage, compiling evidence for compliance reports. AWS Artifact is a free self-service portal offering instant access to AWS security and compliance reports. It also allows you to manage legal agreements with AWS at both the account and organization levels. You might need AWS Artifact for audits, providing evidence of compliance for AWS services, or understanding your responsibilities under regulatory standards like Payment Card Industry or PCI and Service Organization Control or SOC. Access AWS Artifact directly from the AWS console by searching Artifact. The home page provides options to view reports and agreements. AWS Artifact reports include auditor-issued reports like ISO certifications, PCI, and SOC reports. These audit artifacts help demonstrate AWS security controls, aligning with the AWS shared responsibility model, where AWS secures the cloud and you secure your applications in it. AWS Artifact lets you view and execute agreements such as the AWS Business Associate Addendum or BAA for storing personal health information. Accept agreements by acknowledging terms after reviewing the Non-Disclosure Agreement or NDA. AWS Artifact is essential for maintaining secure, compliant AWS cloud solutions, ensuring adherence to necessary rules and regulations. Imagine you are being audited and need to show AWS compliance with ISO 27001. Start by creating a customer-managed IAM policy called Artifact Read ISO. This policy allows access only to ISO certification reports in AWS Artifact. Next, attach this policy to an IAM user like auditor in your AWS account. In the IAM Management Console, add permissions to the user by selecting the Artifact Read ISO policy. This ensures the auditor can access only ISO reports. Log in as the auditor to test the policy. On the AWS Artifact homepage, click View Reports. Attempt to download a non-ISO report and you'll see a permission required message. Search for ISO 27001, download the report, and it works. For multiple auditors, attach the policy to an IAM user group instead of individual users. This follows best practices and simplifies management. Use AWS artifacts to securely share reports as each is watermarked with a unique ID. By leveraging IAM policies, you can provide fine-grained access to ISO reports in AWS Artifact, ensuring secure and compliant sharing with auditors. This approach maintains security, and others to the principle of least privilege. IAM user groups in AWS are essential for managing multiple users efficiently. They authorize access to AWS resources through policies, simplifying permissions management. Creating a user group is straightforward. First, name your group meaningfully. Next, add users to the group. Finally, attach permissions via policies. This setup streamlines access management for specific rules. User groups can have AWS managed, customer managed, or inline policies. For example, a developer group might have policies granting access to necessary development resources. Adjusting group permissions updates access for all members instantly. Adding users to a group is simple. Select the group, click Add Users, and choose the desired users. Removing users follow a similar process, ensuring flexibility in user management. AWS accounts have a default limit of 300 groups and users can belong to up to 10 groups. Each group can have 10 policies. For efficient management, apply permissions to groups, not individual users. Always check AWS for the latest limitations. IAM roles in Amazon Web Services or AWS allow trusted users, services, and applications to adopt temporary credentials to access resources. Unlike users, rules can be assumed by multiple entities, providing flexibility and security for resource management. Rules are designed for temporary access, generating new credentials each time they are assumed. This means roles do not have long term credentials like passwords or access keys, enhancing security by eliminating the need for embedded credentials. Each IAM role has associated policies that define what resources can be accessed. Additionally, a trust relationship specifies who or what can assume the role, such as a user, an AWS account, or an AWS service, ensuring controlled access. IAM roles are versatile. They grant temporary access to users who don't usually need it, allow cross account access, enable AWS services to access resources on your behalf, and support federated users authenticated via systems like Active Directory. This flexibility makes IAM roles essential for secure and efficient AWS resource management. AWS service roles enable services to access resources within your account on your behalf. For example, an EC2 instance can assume a role to interact with other AWS resources like Amazon S3 without storing credentials locally. Imagine an EC2 instance running an application that needs to access Amazon S3. Instead of embedding credentials in the application, assign an IAM role to the instance. This role grants necessary permissions, simplifying management and enhancing security. Service roles streamline permission updates. If multiple EC2 instances use the same role, altering permissions in the role updates all instances simultaneously. This efficiency is lost if credentials are embedded locally, requiring manual updates. Service linked roles are pre configured with specific permissions for certain AWS services. For instance, AWS Systems Manager uses AWS Service Role for Amazon SSM to manage resources. These roles are created automatically and are non editable, ensuring secure operations. AWS service roles and service linked roles offer secure, efficient ways to manage permissions across AWS services. By leveraging these roles, you can enhance security and simplify administration, avoiding the pitfalls of local credential management. Sometimes you need to grant temporary access to Amazon Web Services resources. The best way is to allow a user to assume a role with specific permissions, ensuring security. To create a role, navigate to the Identity and Access Management dashboard in your Amazon Web Services Management console. Select Create Role, choose the trusted entity as your account, and attach the necessary permissions like Amazon S3 Full Access. Next, ensure the user can assume the role. For example, user steward needs an inline policy allowing him to use the secure token service assume role action. This policy links steward to the role S3 full access rule. Once permissions are set, steward can switch roles. By selecting switch role in the console, entering the account ID and the role name, steward gains the permissions of role S3 full access, temporarily replacing his original permissions. After completing tasks with the role's permissions, steward can switch back to his original user profile. This method ensures secure, temporary access without compromising security best practices. Web Identity Federation allows users authenticated by external providers like Google or Facebook to access AWS resources. For instance, a mobile app needing Amazon S3 access can use this method. Users authenticate through a web identity provider, receive a token, and exchange it for temporary AWS credentials using the Assume Role with Web Identity API. SAML 2.0 Federation is ideal for authenticating employees using existing directory services like Microsoft Active Directory. It uses security assertion markup language to exchange authentication data. Employees authenticate via Active Directory and SAML issues an assertion to AWS Security Token Service, granting temporary credentials for accessing AWS resources like S3, EC2, and RDS. Identity Federation is a trust-based authentication method between two providers. One acts as the identity provider, authenticating users, while the other, the service provider, grants resource access. This method allows users to authenticate with third-party credentials, streamlining access to services. Federation minimizes administrative tasks and supports single sign-on solutions. It reduces the need for multiple IAM accounts, especially in organizations using Microsoft Active Directory. By leveraging existing credentials, it simplifies access management and enhances security, providing a seamless experience for users accessing AWS resources. Identity-based policies in AWS IAM are attached to users, groups, or roles controlling their permissions. They can be managed or inline. Managed policies are stored in the IAM library, while inline policies are embedded directly into an entity, creating a one-to-one relationship. Resource-based policies are linked directly to resources, not identities. A common example is an Amazon S3 bucket policy, which specifies who can access the bucket. These policies include a principal parameter defining which identity can access the resource, unlike identity-based policies. Permission boundaries set the maximum permissions for a user or role without granting permissions themselves. They act as a guide rail, ensuring that even if a user has full access through identity-based policies, the boundary limits permissions to a defined level. Service control policies or SCPs are used in AWS organizations to define maximum permissions for accounts or organizational units. They don't grant access but restrict it, ensuring that even with full permissions, certain services can be denied at the account level. Understanding these AWS IAM policy types, identity based, resource based, permission boundaries, and SCPs, helps manage permissions effectively. Each serves a unique purpose, ensuring security and control over access within your AWS environment. Choose wisely to maintain robust security practices. IAM policies are crucial for defining access in AWS. They are formatted as JSON documents or JavaScript object notation. Each policy contains at least one statement, which is enclosed in curly braces or square brackets for arrays. Key elements include version, which specifies the policy language version, and statement, the main component. Within a statement, you find SID, effect, action, resource, and condition. These elements define access levels and the resources they apply to. The SID is an optional identifier, while effect can be allow or deny. Action specifies API calls and resource uses ARNs or Amazon resource names to identify resources. Conditions control when permissions apply based on criteria like IP addresses. Consider a policy allowing full CloudTrail access if the source IP is within a specific range. Another example grants RDS access excluding the delete DB instance action. Resource-based policies, like those for S3 buckets, can specify principles and conditions. IAM policies structured in JSON are powerful tools for managing AWS access. Understanding their syntax and elements helps ensure secure and efficient resource management. Creating IAM policies in AWS can be streamlined by copying existing AWS managed policies. Start by logging into the AWS Management Console and navigating to the IAM dashboard. Select Create Policy and choose Import Managed Policy. For example, import the Amazon S3 Full Access Policy. Modify the JSON to specify your own resource, such as a specific Amazon S3 bucket. Name your policy and click Create Policy. The AWS Policy Generator simplifies policy creation through drop-down selections. Access it by searching AWS Policy Generator online. Choose IAM policy and add statements. For instance, allow Amazon S3 actions by selecting desired actions and specifying the bucket's Amazon resource name or ARN. Add conditions if needed. Once satisfied, generate the policy, copy the JSON, and paste it into the IAM console to create your policy. To create a policy from scratch, use the IAM console's Visual Editor or JSON tab. Select services and actions, specify resources, and add conditions like multi-factor authentication. The visual editor resembles the policy generator, offering a user-friendly interface. Once configured, review and name your policy, then create it. This method provides flexibility for those familiar with the JSON syntax. Every access request in AWS begins with authentication. This step ensures the user making the request is valid and recognized by the system. Once authenticated, AWS determines the context of the request. This involves identifying the service or action requested, ensuring relevant policies are highlighted. Policy evaluation is crucial. By default, access is denied unless explicitly allowed. If a deny exists in a policy, it overrides any allow, ensuring strict access control. Policies are evaluated in a specific order: organizational service control policies, resource based policies, IAM permission boundaries, and finally, identity based policies. This sequence ensures comprehensive access control. Consider steward, who wants to upload to an S3 bucket. The evaluation checks each policy type. No deny is found, and his group policy allows S3 actions. Thus, steward's request to upload is permitted, demonstrating AWS structured access control process. Unencrypted data, known as plain text, is readable by anyone with access. While harmless for non-sensitive information, sensitive data like customer records must be protected from unauthorized access. Encryption transforms plain text to unreadable ciphertext using mathematical algorithms and keys. To revert ciphertext back to readable form, an encryption key is essential, ensuring data security. Symmetric encryption uses a single key for both encryption and decryption. This method requires secure key transmission as interception poses risks. AWS Key Management Service or KMS mitigates this by securely managing keys. Asymmetric encryption employs two keys: a public key for encryption and a private key for decryption. The public key can be shared freely, while the private key remains confidential, enhancing security. AWS KMS utilizes both symmetric and asymmetric encryption methods. It acts as a central repository, managing and storing keys securely. By issuing decryption keys only to authorized users, AWS KMS ensures robust data protection, balancing speed and security efficiently. The AWS Key Management Service or KMS is a managed service that stores and generates encryption keys. These keys are crucial for encrypting data across various AWS services. KMS keys must remain highly secure. AWS administrators cannot access or recover your keys if deleted. As users, it's our responsibility to manage and restrict key usage within our environment to protect our data. KMS consists of several key types. Customer managed keys are fully controlled by us. AWS managed keys are created by AWS services. AWS owned keys are used across multiple accounts. Data keys encrypt data outside KMS, and HMAC keys verify message authentication codes. KMS provides encryption at rest, not in transit. For data in transit, methods like Secure Sockets Layer or SSL are needed. Data encrypted at rest remains secure during transfer, as it stays in ciphertext form. Encryption is vital for compliance and security. KMS integrates with AWS CloudTrail to audit key usage, tracking API calls like decrypt and encrypt. This ensures transparency and governance in your production environment. AWS Key Management Service or KMS is a powerful tool for managing cryptographic keys. It enables secure encryption and decryption of data, ensuring data integrity and confidentiality. KMS supports both symmetric and asymmetric keys. Symmetric keys use the same key for encryption and decryption, while asymmetric keys use a public-private key pair. Symmetric keys remain within KMS, ensuring security. KMS keys can be customer managed, AWS managed, or AWS owned. Customer managed keys offer control over permissions and management. AWS managed keys are automatically handled by AWS, simplifying administration. Hash-based message authentication codes, or HMAC, verify data integrity using cryptographic hash functions. Data keys generated by KMS encrypt data outside KMS. They can be symmetric or asymmetric, supporting various cryptographic operations. Key material is crucial for cryptographic algorithms. It can originate from AWS KMS, external key managers, or Cloud HSM. Key rotation is recommended for security, ensuring key material is regularly updated without changing the KMS key itself. Securing your key management service or KMS keys is crucial. While identity and access management or IAM policies control access to resources, KMS key policies are essential for managing access to your keys. Let's explore how these policies work. KMS key policies are resource-based and tied to each key. They determine who can administer, access, and create grants for the key. These policies are written in JSON similar to IAM policies and include elements like resource, action, and principle. Key administrators manage KMS keys but cannot perform encryption. They can update key policies, potentially granting themselves user access. Key users defined in the policy can perform cryptographic functions like encrypting and decrypting data. Grants allow temporary delegation of permissions without updating the key policy. Created via KMS APIs, grants enable AWS services to perform encryption operations on behalf of users. They are crucial for integrating services like Elastic Block Store or EBS. To secure KMS keys, understand key policies, define administrators and users, and utilize grants for temporary access. This ensures robust control over your encryption keys, safeguarding your data effectively. To create a new key management service or KMS key in the AWS Management Console, start by navigating to the Key Management Service. Click on the orange Create Key icon to begin the process. Choose between a symmetric or asymmetric key. For this demonstration, select symmetric and set it for encryption and decryption. In advanced options, keep the default KMS origin and single region key settings. Next, define the key policy. Select key administrators such as Cloud Academy and Steward who can perform administrative actions. Choose users like Steward who can use the key for cryptographic operations. Remember, administrators cannot use the key for cryptographic tasks.
Review your selections, including key configuration, alias, and policy. The policy outlines administrators and users, detailing their permissions. Making any necessary edits directly in this editable document before clicking Finish to create the key. Once created, view your KMS key under Customer Managed Keys. Check General Information, Key Policy, Cryptographic Configuration, and Tags. Use the Key Rotation tab for automatic key material rotation. Remember, disabling or deleting a key affects data accessibility. Understanding access to a key management service or KMS key involves three methods: key policies, identity and access management or IAM policies, and grants. Key policies define who can access a KMS key. IAM policies can manage access if the key policy allows it. Grants provide temporary permissions. These methods work together to determine access levels. Let's explore access scenarios for 4 users: Alana, Danny, Carlos, and George, with 3 keys: key A, key B, and key C. Alana can access key A and key C due to her AIF permissions and key policies. Danny can only access key B through the key policy. Carlos has encrypted access to key A via IAM and access to key B through the key policy. George can access key C for cryptographic operations and create grants, but not key A or key B due to key policy restrictions. In summary, understanding KMS key access requires analyzing key policies, IAM permissions, and grants. Each method plays a crucial role in determining who can perform cryptographic operations, ensuring secure and controlled access.
Thank you for watching this video. And don't forget to subscribe to Tech with Shaping Pixel.